All right, welcome to Iglooconf 2024. I'm Pasi Huuhka, one of the organizers of the conference. Here's our Wi-Fi. You can log in to that pretty easily. And then there are also electricity under your tables. Not for everybody, but share it so everybody can get some. If you don't know what Finland Azure User Group is, well, it's the largest Azure user group in Finland. We are supporting 2,600 members roughly, and Iglooconf is our biggest event we organize. We also have some smaller meetups, multiple of them every year. Here are our sponsors. Let's give a big hand to Elisa, Azure, Go4, Microsoft, Mallow, Innofactor, and Sealy. Without our sponsors, we could not make this happen, so thank you. Here's the map of the hotel venue we are at. So this is Caladan on the green here. Then next to us is Arrakis, and the bathrooms are at the bottom. You saw the breakfast area next there, and then we have our sponsor booths and also the place where you can get our badges next to the breakfast area. And at the top here is the place where we'll be having lunch later on. Today's agenda, you can always see this agenda at iglooconf.fi and click the names of the presenters or the presentations for further information. But the agenda is that we have 2 sessions here before lunch. We have Jussi and Gert here speaking in this room. Then we have a lunch, and then we have 2 more sessions here, a break, and 1 more session there. And then to end the day, we have a panel of all of these experts we have here. In this room, our speakers are sitting here in the front, if you want to check them out and hear them maybe heckling each other a little bit. And after the event today, we have after party at the Azure office. I made this very confusing map for you guys, but if you want, you can just actually walk in a straight line to get to Kaivokatu here. Last thing, we have a live stream, 2 of them on those addresses, also on iglooconf.fi. We can check it there, you can share it with your colleagues and so on. And also in social media with the Iglooconf hashtag. And one more thing about the agenda, we aim to have very technical sessions this time without that much co-pilot stuff, but at least we have a very great set of speakers coming up here. And without further ado, let's start the event with our first speaker, Jussi Roine. Give him a big hand.
Thank you, thank you. Alrighty. I was once told that when you're presenting something, it's a measure of your skills if you can get the projector to show the pictures of your slides. There we go. Good morning. Glad to see so many of you here, and people in the live stream, make a note of the after party. I'll meet you all there. I hope it will fit everybody in here. Let's talk a bit about Azure and security and AI and everything that sort of boggles the mind and keeps us busy this year and I think for the foreseeable future. To get to know me, I would like to say go to Google and Google me, you get to know me, but For some reason, that doesn't work anymore. Let's get back to that in a bit. But there's been 3 defining events in my life that has brought me here, and I hope you here as well. The first one was a VIC-20 that my parents had a foresight to acquire in 1982. I was at the ripe age of 5. Anybody else here using VIC-20? There's 1, 2. Yes, I like you already. And if somebody's thinking I wasn't born yet in 1982, that's fine, you can still stay here. And if you do a raise of hands in the live stream, that's great as well. I cannot see you, but you're sort of participating properly. And then Microsoft came out with MS-DOS 3.3, that's my absolute favorite. 6.0 was okay-ish, 3.4, we don't really talk about that. But perhaps one thing that has sort of modified me more than I care to admit, in a couple of years ago, my third son was born, and at the same time I was building a house. I was at the summer cabin enjoying my short summer holiday, and the contractor called me and said, "Jussi, we have a huge problem now. I sent the problem to you in Excel. This is the Excel that I got. It is the tightness of the land mass of the excavation that we need to do for the house. And there's a measurement, which is the purple bars, the result of that, and then there's a requirement, which is about 2.2 of something, I don't know what it means." And they said, "Yeah, you're not going to pass on this one." And I had spent a lot of money and time to get to that point. So we had a couple of really frantic days trying to figure out how do we tighten the landmass so that it can sustain a house. And finally, I knew nothing else to do. I called the guy who did the measurements and said, "I've got 5 people who have been working 20 years in the construction sites. They don't know what to do. So can you give us some advice? How can we fix this?" The guy goes, "What do you mean? You don't have a problem." I said, "Well, it's below the requirement." "Oh, no, the Excel is upside down. It's actually over the requirement. So you're all good." I'm like, okay, this probably modified my thinking more than I care to admit. Alrighty, so we'll talk a bit about Azure today, then we hop on to generative AI. I promise not to spend too much time on Copilot because you are all using all the Copilots. The latest number I've heard is that Microsoft has 64 Copilot services. Then there's one number, 142 Copilot services, because you can factor in each individual capability in GitHub Copilot Chat as a separate Copilot SKU. And then let's talk about security. And the sort of underlying message throughout this morning for you is that we all need to learn to eat more vegetables. There's a story behind this. If you have great questions, I do have a positive broccoli. I'm happy to hand these out. I have a couple of these with me. If you're remotely on the live stream, hop in the taxi, get here, so you have a chance to get this. All righty. So, quick show of hands, how many of you identify yourself as a developer? Somebody who lives in VS Code, Visual Studio. Some people prefer using Vim for some reason. Okay, about 10 people. How about how many of you identify as an IT pro, architect, enterprise architect, meaning mostly PowerPoints? Not too many, a couple. And lastly, how many of you identify as managers, C-suite, CISOs, CEOs, people who manage? Okay, about 1/4. Good stuff, good stuff. So let's talk about Microsoft Azure. I was working at Microsoft. I had just relocated to Dublin, Ireland. I wanted to see the world. I applied to all Microsoft offices in the world where I knew I could speak the language or I could learn the language. So France was out immediately. But Dublin welcomed me with open arms. I was at the office one evening because we like to do long days there. And there was an email from Ray Ozzie at the time. He was the CTO at Microsoft. And he sent a message that Red Dog is now available for internal consumption. And I was like, I've heard of this. And what he meant was Windows Azure, because Steve Ballmer had the foresight to call it Windows Azure, because obviously nothing else would run in the cloud. You want to run Windows in there. And I whipped out my laptop. At the time, this was 2008, October-ish. At the time, Azure was a setup.exe. You would download that from the file share, not from SharePoint, obviously, And then you do setup, next, reboot, and you would get this super great XML file that allowed you to configure how many instances of the web and worker roles you would like to run. This was Azure at the time. I reached out to the product group at some point to ask, so why is it called Red Dog internally again? They're like, well, it's not official, but sort of the story is that we were driving around maybe in Texas and we wanted to have a great code name for Azure, and there was maybe a gentleman's club nearby that was called Pink Poodle, so we needed this to be something more aggressive, so it became Red Dog. And then we got Silverlight. My oldest son was born at the same year that Microsoft brought out Silverlight, and I'm not sure which shaped my thinking more, the birth of my son or Silverlight. I did sit at a couple of Microsoft events doing Silverlight labs. It took about 60 minutes to get a clock face that had the second hand going through in 60 seconds. Then you would complete that and you were a Silverlight expert. And then Microsoft again had the foresight to build the whole admin interface to Azure with Silverlight. And I'm still not really sure why they chose that, but I'm super happy they didn't stick with that. But at the time, Azure was relatively simple because all you had to do was to know about 5 services: Azure SQL, storage, web worker roles, and something else that I forget, maybe Azure Active Directory at the time, which was called Windows Azure Active Directory because Windows was super important at the time. So that was easy. Today, Azure is about 200 services, depending on how you calculate them. It's impossible to know them all. And I frequently have meetings with customers that I show up in the Teams call at 9 o'clock or at their office at 9 o'clock, and they ask me, Jussi, what do you think about this new public preview feature that was released last night at 3:30 in the morning? I'm like, oh, gee, I don't know, I was sleeping, but let me have a quick look what they announced, so then I can maybe become an expert in that. And then we got the classic Azure. I sort of like this. It was fairly monolithic, meaning the portal was super slow. It was probably running in Redmond. They didn't realize they had users in Europe at the same time. And it sort of worked. It was relatively easy still, but you had to struggle a lot to get stuff running. So in a way, I'm happy that we are up to about 200 services, and you can focus on a subset of those. So when we were thinking of Azure, Eurostat, the ministry in the EU region that is producing statistics like this, the use of public cloud services and platforms in the EU region for enterprises. And perhaps don't focus too much on the enterprise word, because the definition, I did look that up, the definition from Eurostat for an enterprise is an entity of 1 or more persons running a business. So in a way, I have an enterprise myself as well. And the use of cloud computing services in the EU, why am I getting a reminder? I should have Outlook off. The use of cloud computing services, Finland, at the end of 2023, is leading the pack. So Finland is first on the left. We beat the Swedes. That makes me happy. Anybody from Sweden here? No? If somebody on the live stream, you need to make up for this. We'll see you next year. I think we can still beat you. Then Denmark, Ireland, Italy, and so on. Norway, though, is doing relatively well. But if we look at the EU average on the use of cloud computing services, this factors in Azure, AWS, Google Cloud, and so on. If you look at that, the average, it is a hair over 40%, which means there's plenty of ground to cover in terms of utilizing public cloud services, but also for building hybrid, still building on premises that might eventually move to the public cloud as well. And sometimes then the total opposite happens. For those of you who work as architects, you've seen this picture 1,000 times. This is the official reference implementation for the enterprise landing zone architecture from Microsoft. It looks great on paper. You have a look at this, you can see your favorites. Active Directory is still there because everybody needs that, right? We have the Entra ID, meaning Azure Active Directory. Then a bunch of management groups dozens of subscriptions so that we can do subscription vending and democratize the whole access for this one. And I've seen dozens of implementations of this, and all of those implementations are carbon copies of this one, because this is what Microsoft made as a reference, so let's use that one. You perhaps use Bicep or Terraform so that you can do it in code. And a couple of times I'm looking or auditing something like this, and I'm asking the customer, so this seems to be running, so any problems you're having with this? And they're like, well, no, it took 18 months to deploy. It cost us 250,000 euros to design. Okay, sounds quite enterprisey. So what do you do with this? Oh, no, we don't have any production workloads yet because we exhausted our resources just to get this sort of framework up and running. And then you start thinking, well, is there perhaps something the other nations in the EU region get that we don't get in the Nordics, because we want to go all in with something like this? So I'm often advocating for something like, this is a nice reference, this is probably not the thing you want to deploy as is, you want to adapt this for the customer. So my own lessons with Azure is, this was in September 2022. I woke up on a gray Monday morning, and I get select notifications on my watch. I used to get WhatsApp and Signal, and it just lighted up like a Christmas tree. So I get just select notifications on this one, and there was one notification from my online bank, and it said, Microsoft Ireland has been trying to charge you 49,555 euro, but it failed because I didn't have sufficient funds in my account. I was super happy for that. And I was like, okay, let's see what's happening. Is this a phishing attempt? Is this somebody from Microsoft back from my past when I used to live in Dublin asking me for some payback, or is this something else? And there's an email saying that the current cost of my test Azure subscription with a budget of 150 euro is 53,000 euro. The forecast is 325,000 euro. And we're expecting your immediate payment for this 53,000. And I was like, okay, let's start digging on this one. And I spent a couple of hours trying to dig through that, and then I got another alert that that Azure subscription was at 161,000 euro spent money. We'd like to get your money immediately, please. I started escalating that to people I know in Redmond, to the official billing and accounting department. I locked down my credit card so they couldn't just forcefully do this. And the reason for this was not that I was doing Bitcoin mining in Azure. That doesn't really work that well. The reason for this was that I was running a public preview software. The software was called Defender External Attack Surface Management, Defender EASM. The whole purpose of that is that you put in assets as seeds, meaning your domain names, AS numbers for routing, web addresses, IP address ranges, and it starts going to the Microsoft signals and graph and databases to build a full picture of your assets, how it looks externally, so that you can understand what you're exposing. And I tried to do that to my personal domain, jussiroinen.com. It has one IP address. I figured, let's see how this works. And that failed. And then Microsoft had said, try something else. And what I had tried the previous night, I put cloudflare.com, because I figured maybe they have something. They have 80 million assets. One asset is 1 cent per day. So that quite rapidly ramped up the cost for me. And long story short, this took 12 calls, 12 meetings with Microsoft that kept escalating higher and higher. Each call started with, so Jussi, tell us again why you shouldn't be paying us this money. I'm like, well, because I don't think I really consumed this. There's a bug in your system, or it's not logical. If I can add one domain in a text box, press enter, and that makes 50,000 euro immediately in cost, that's not how the public cloud should work. How did we end up with? I ended up paying 55 euro. Super happy for that. I didn't have to sell the house. The kids did not have to move under the bridge with me, and we're all good since then. I haven't deployed the service since then, though. So for the past couple of years, I've been working quite deeply with all aspects of security with customers, meaning Azure, Microsoft 365, on-premises, VPNs, Wi-Fi, routing, on-premise deployments, and everything in there. Security goes everywhere. And what I wanted to do after 2 years is, what sort of skills do you need in a fast-paced IT and development environment as a professional to succeed with these customers, these challenges? And I built this mind map. I switched to a MacBook last year, and obviously when you use MacBook, everything is super tiny because you have the resolution is so high. So I did a bit of a zoom in for you. And it really opened my eyes to try to understand that you need to understand an awful lot about infrastructure, not everything, but you still need to understand how Active Directory works, how GPOs are deployed, how do they synchronize, how do you do cloud sync to the cloud. You need to do scripting. PowerShell typically, but I see a lot of people doing Python nowadays. I still struggle a bit to make the hop because they have this weird notation of having tabs in there, and I just can't live with that. And then you have to do data integration, you have to be able to modify endpoints, and primarily everything revolves around identities. And when I say identities, I don't mean that do cloud synchronization from AD to Entra ID and call it a day. That's probably the first step, and then you have about 55 steps to complete on that one. How do you do multi-factor authentication? How do you do single sign-on? How do you synchronize different external systems? And how do you do governance for all of that? Microsoft 365 is interesting in this context, because even if we talk about Azure, a lot of the stuff that the users will be using will be in Microsoft 365, and that bleeds back to Entra ID and all the new capacities in there. And then strictly on Azure side, I often hear from experts nowadays when we start a new project, the first question is, so Jussi, we are doing this project for a customer, we are planning on deploying stuff. Do we use Bicep or Terraform? And that seems to be the defining existential question, which one do we use? And I often say, I don't really care at all, because we are 12 months away from even writing the first line of a Bicep module. We have to design, we have to plan, we have to do the governance, we have to do everything, and then maybe eventually we get to deploy something. And this tells me also that Azure and the projects and deployments that customers want, it has matured quite a bit. So instead of going in and starting on the first day to deploy something, it's much more about the governance, it's much more about managing, planning, designing, and also doing cost management, which I think I'm an expert nowadays. And lastly, everything else, I did add Defender EASM in there, just so you know, to avoid the cost. So generative AI. Microsoft did a nice survey early in 2024. What are the top of mind topics for leadership teams in companies? And generative AI, not surprisingly, was the first major topic everybody is thinking of. To me, this often means, well, everybody's thinking about ChatGPT. How do we use this? How do we integrate this? How do we build a wrapper around ChatGPT and do business with this one? Automation, cybersecurity makes me smile because there's a lot of business in here. But then there's stuff like virtual and augmented reality. And Apple Vision Pro was announced around the time they did this survey, but it didn't seem to make a huge dent in the demand. But I'm looking at quantum computing. There's a session on quantum computing later today, and it's super interesting, but I'm entirely not sure where and how and why would you use it, and that's my limitation, so I need to attend that session as well. A Danish think tank did another study on the expectations of generative AI, meaning that 2/3 of Nordic organizations plan to use it more in the next 3 years. And I think we will all use it more, do we want it or not, automatically or manually. But only half of these organizations expect that AI will make them more competitive. So why would you use it if it doesn't make you more productive, more competitive, give you something extra in there? So my bet in here is that 2 years from now, I will go through a bunch of companies in Finland and look at their financial records. Are they becoming more productive? Are they more profitable? And we are not sure quite yet. We know how to use the services, we know how to build them, we know how to integrate AI to a bunch of things, but is it doing that much to us? And I'm not really sure. Let's talk about this in a second. But only 1/3 expect to use AI in management work. So does this mean that the managers are safe, their jobs are not going away, but the developers, the IT pros, the architects, their work will be automated? I think it will be the opposite around. And I'm not sure which is better, that the manual work that I do gets automated and taken away by AI, or that I would have a manager that would be an AI that would manage how I work. I perhaps prefer the first option in here. So management often wants great generative AI solutions. I've been building a bunch of those, mostly using Azure OpenAI, but often the request nowadays, at least in Finland, is that we want this sort of a solution, but all the data that we plan on feeding, for grounding it and for actually utilizing, all the data needs to remain in Finland. So it cannot leave the boundaries. We cannot run this in West Europe. We cannot run this in Sweden Central, which means we run the inferencing of those models locally. Typically, we set up a server with 4 GPUs, a lot of RAM, and run everything in there. It works beautifully. But then we're sort of going back to on-premises and building something local. It warms my heart because it's nice building servers, but at the same time, the expectation is that we're building an Eiffel Tower because everybody's benchmarking against ChatGPT or whatever Microsoft is showcasing. But then when you start building this, and I hear this often from friends who also work in this space, is that, well, the customer said that they have a budget of 3.5 days. What can we build with this? Well, not much we can do. A simple React web interface with a text box that barely works, not optimized for mobile, and then we can call a REST API that calls our Azure OpenAI instance and does a bit of prompt engineering and flows. That's about it. It's far from building an Eiffel Tower. I think it took a little bit longer to design and build that as well. So the landscape is, for end users, it's typically ChatGPT. They want to use this one. How many of you here have a paid ChatGPT subscription, the Team or Plus or something else? About 1/3 of the audience have that one. And initially the problem obviously was that we weren't sure how the data that you feed into ChatGPT, how the data would be used to train the models later on. Now they have controls for that, but initially we just started using it. ChatGPT got up to 100 million users. Nobody cared what they pasted in there. And I was a bit worried about that. IT pros, developers prefer Azure OpenAI and probably some other external engines, or they run them locally. And managers, they just want Copilot. They want nothing else. Because they've been hearing how Copilot will save everything, it will automate and optimize your work. In 1st of February, when we got Copilot for Microsoft 365 commercial licensing, I bought the license to everybody in my company. And you could only buy the annual license, meaning you ended up paying about 300 euro per person for the full year. Everybody wanted to have that. 2 days later, I'm asking people, so how are you getting the value from Copilot for Microsoft 365? And somebody said, well, it's not really giving me what I'm expecting it to give me. And since then, it has evolved quite a bit. The best use case I have for generative AI, if somebody were to ask me, what's the best AI productivity tip that you can possibly come up with? It's super simple, but it's relatively great. You need to build a PowerPoint presentation. You go to the web, you find a nice Microsoft Learn article on the main topics that you need. You save that as a Word document, save that to OneDrive, feed that to Copilot for Microsoft 365, and give a nice prompt. Build me 20 slides on this, the main topics are this, and this. Take the pictures, take the structure. It builds a fairly impressive PowerPoint for you in about a minute. And then you can tweak and do whatever you like. I don't use it for this. All of the slides I've built manually. But if I need to do a quick tutorial for something, can you tell us about NIS2? Sure, let me get the base stuff in place so I don't have to do copy-paste and I don't have to think that much. That probably saves me a couple of hours per presentation that I can do. But beyond that, it's mostly tiny, small things that we need to automate, and that's about it. So a real-life example on using generative AI. So what I often do is I run large language models locally. I'm using a MacBook, and it's fairly performant on even the larger models. So this was built with Code Llama. And I had a customer, we were working with something for them, and on a side chat, they asked me, so Jussi, we need an Azure SQL database with one table. Roughly, the structure should be this, and we need to store the data for 30 years. Can you guarantee it will be stored in Azure for 30 years? And there's some limitations for that. And I said, yeah, this is not a problem. And I know how to do SQL statements, T-SQL. But it's been a couple of years that I really did that. So I fired up Code Llama, I gave it a bit of instructions. I need this, and this, did a couple of prompts, and it gave me this. This took me about 2 minutes. 1 minute to spin up the Code Llama LLM, another minute to do prompting. And I got a fairly nice working SQL statement to create a single table. What do I tell my customer? What's my invoice for this one? Is it 2 minutes out of my hourly rate? Or is it the value that I'm bringing? Can I say, well, this took maybe a day or two to come up with the knowledge to spin all of this up? No, that's not fair. So I ended up charging 30 minutes for this because I needed to think about this for a little bit. Everybody was happy. Then they came back to me and said, well, we need a trigger that when somebody does an insert in the SQL, it needs to add a value in one of the columns with a random value that combines different things. I had the old chat open, meaning I had the grounding and the historical data. I went back to that chat, copy-pasted the request from the customer's email, came here, pressed enter, 10 seconds more, I have a nice looking trigger. I couldn't come up with this by heart. I would have to look it up. How do I do a trigger with these specific things? And this took an extra 10 seconds. Can I now go back to the customer and say, well, this is an extra 30 minutes because I did the heavy lifting here? No, I'll just let it slide because this is the kind of stuff we used to spend our time on. Now we just get it done and we continue with the actual work. And for the customer, this is probably the actual deliverable. For me, this is a meaningless exercise that takes 2 minutes and it's done and I forget how it even works any longer. But they will probably call me in 29 years and ask, is the data still there? And based on the Finnish official age when you get to retire, I will still be working in IT 29 years from now. So I need to store these PowerPoints to come back with them. But then Microsoft said on LinkedIn that if you use Copilot, you can be in 3 meetings at once. This might be the productivity that they are looking into. I'm a bit worried on this one, and I did dig a little bit deeper. What do they mean with this? It means that you attend one meeting, you do not attend those 2 other meetings, but you're following those meetings because in the new Outlook you have that capability, so that you do not decline or say maybe, but you follow that, but you're not present. Then you get the transcript, and Copilot will go through that transcript and tells you what action points were given to you on those meetings. And people are now asking, could I have like a virtual persona, maybe in the metaverse, that would join the meeting on behalf of me, take notes and respond in my voice when somebody's asking, Jussi, can you do this? And then it would say yes or no. And pretty soon I'm thinking, well, why can't I be on the beach enjoying the sunshine and my virtual personas would attend 15 meetings at a time, get me the action points, and I would have an agent that would complete those. What would be the value? Probably great. What would be my salary then? Probably not that great because I'm not part of that formula anymore. Another case that really opened my eyes is COBOL. Anybody here worked with COBOL in a professional capacity? There's one. I feel your pain already in here. Feel the pain as well. I got a call a year ago in the winter. I got a call from a job agency. They were trying to find somebody to work with COBOL in a professional capacity. And somehow they found me. I don't have COBOL in my LinkedIn profile. I've never worked with COBOL besides looking at somebody else doing COBOL. I feel I'm young and the guy doing COBOL was super old at the time. And they asked me, Jussi, we have a great opportunity for you. You need to relocate to Lapland for 11 months. You need to be at the office 5 days a week at a steel factory, and you need to fix the COBOL that they have. And this will take 11 months. How about it? I'm like super tempted, but let me think, let me talk with my family. I spoke with my wife, so what do you think if we, move to Lapland, get the real winter experience and see Santa and everything else, and I get to work in COBOL? She was like, yeah, you can go and I'll change the locks in the meantime. Let's see how that goes. But what I did do, I went to Google, and all the COBOL books from 1985, they're public domain now. So you can download all the books if you really want to learn COBOL. I downloaded all the PDF books, I fed them to my locally hosted Gen AI LLMs, and I asked it, can you teach me COBOL now? How do I do hello world? How do I do this? How do I do that? And I got immediate answers on all of those, and they seem to work. I started thinking, could the virtual Jussi relocate to Lapland and work in an office where the door is locked, and whatever requests they have to fix COBOL, I would just do them virtually with AI. I tried proposing that approach, that I would get the full salary, I would stay here in Helsinki, but I would fix the COBOL problems, and if they have things, they would email me. They were like, no, this is not how it's going to work. You have to be there physically at the steel factory to witness the beauty of creating steel. So we didn't come to a deal. Another example, and this is probably a lesson for me, because there were some things I was super rusty on. There's a free software called LM Studio. It runs on macOS, Linux, and Windows as well. This is how it looks, and you can tell it's a great software because the logo is made in ASCII, just like in 1995. So this always implies to me this is something awesome. What you can do with this is you can download openly available large language models and small language models as well. So what I ended up doing, I ended up downloading Phi 3 from Microsoft, which is a small language models, runs on the edge, meaning Raspberry Pis and devices with less capabilities, but it runs super fast on a laptop as well. So you download Phi 3, and then when you've downloaded that one, it can host a REST API for you locally, meaning that it spins up a server which is compatible with OpenAI REST API. So you can do your development locally, and when everything works, you just point it to your Azure OpenAI or your OpenAI instance, and that way you save up on those tokens when you're doing development. And the nice thing is that it gives you a curl example to try, how does this work? So you do curl localhost, blah, 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 and then it gives you the response back from Phi 3 or other models that you choose to use. So I spun this up, and once I had it up, I was like, well, I'd like to create a web page that now talks to the REST API that I have locally. And the web page needs to be in HTML, nothing fancy. So I go to GitHub Copilot chat in VS Code, and I give it the curl statement. This is the curl statement, the endpoint request. Give me an HTML page that conforms to this one. I don't really want to think anymore. I perhaps know how to do this, but I don't want to spend any time on this anymore because this is meaningless in the sense that I would just want to get it up and running. Then I can tweak it further. GitHub Copilot thinks for maybe 10 seconds. It gives me a nice looking HTML. There's some weird stuff like the fetch. I was like, well, this didn't exist in 1998 when I studied HTML, so this is new. And it correctly picked up everything, even the sample roles always answer in rhymes, it says. I needed to tweak that one. And if it calls the API that I'm hosting locally, if it gets the response back from the small language model that I'm hosting, instead of printing that conveniently for me, it's dumping that in the console log, which is the best place to get debugging messages. I was like, this is awesome. I'm almost like a developer now. It took me 2 minutes to get here. So I run this, but it starts complaining about CORS and missing origin and all those things that typically penalize you in Azure. And I was like, so how do I get around this? Because the HTML file is local, I cannot really fake CORS. So it's telling me, well, now you need to embrace the beauty of Node.js and host this on Node.js to actually get it up and running. And there's probably not too many things I hate more than Node.js, so I figured, help me out here. And it gives me this. So you have an API server.js that has a couple of requires in here, and then it's actually doing the posting directly. So the HTML page is calling this one, and then it's subsequently calling that one. And it's listening on port 4000, but my LLM or SLM is on a different port, so this gets awfully complex quite fast. I have no idea what I'm doing. I'm just getting code and hitting next, next, next. This is like back in the day with Stack Overflow. You just copy-paste something, it works. It's great. So I run this, but now it complains that, how do I run Node.js? So I ask for that, and then it complains about not finding module Express. And I can again go back to GitHub Copilot to ask, how do I run Express? Well, you need to do npm install Express. You get 350,000 JavaScript files locally, but this is awesome, it's super great. I'm glad you chose Node.js and not C# or something more modern. Finally, with all this, it works. I have a browser with a single button. When you click this one, it calls to the API that I'm hosting locally. Nothing happens. But if you press F12, go to DevTools console, it is telling you that this is what we're getting back from here. Again, this took maybe 5 minutes, mostly done with Gen AI. I didn't need to know anything. Perhaps I wouldn't deploy this to production quite yet because VS Code doesn't have right-click publish. But if I ported this to Visual Studio, I could do right-click publish and it would be production ready, really. So again, the meaningless stuff, super easy to do, but I don't really understand what's happening in here. I can read the code, but I haven't internalized that, what is really happening in here. And that's probably the same effect we had for those of you who had a driver's license in the 1990s. The cars didn't have a GPS device at the time. We started getting the TomTom devices at some point. Now most cars have the embedded GPS. So before the time we had GPS, you had a paper map. I was doing a road trip in Barcelona in 1996, and my girlfriend then, she was navigating. We had a huge paper map, and I'm yelling at her which turn to take, and she's like, I don't know where we are. And we're sort of in that phase, a little bit past that one. We have the rudimentary TomTom devices, but nothing super fancy yet, and we're getting there. So a friendly reminder that we should all eat more vegetables. I started a challenge with myself that I need to learn to eat more vegetables, and I started with broccoli because I've always disliked broccoli quite a bit. And if you go to temu.com, you can order positive broccoli plush toys. I have a few extra of these, so if you find me later today, I can hand this out, perhaps. Try to get you to eat more vegetables as well. I read a study that by the time you turn 50, you start losing 1% of your muscle mass unless you do something about it. And I figured, let me eat more broccoli, let me do a little bit more sports, so that by the time I'm 75, before I retire, I can still get out from bed, fire up my VS Code, and actually get productive stuff done. So if you've been thinking, should I eat more vegetables? Yes, we should all eat more vegetables. So I really like Mac OS. It gives me all sorts of things when I'm presenting. Windows never does this for me. Briefly on the language models. Are we in here? There we go. So OpenAI obviously nowadays mostly dominates this space. GPT 3.5 Turbo, super efficient, super cost optimized for most reasoning, for most summarizations you need to do. Then you go for the fancier stuff with GPT-4, obviously. And Azure OpenAI obviously has access to all of these as well, and you would typically use Azure AI Studio. I rarely need the old Azure OpenAI Studio. The new AI Studio is much more capable in that sense. This is the worldview that I often see with customers. GPT this, GPT that, which version, and let's just get cracking on the solution. But Meta came out with Llama 3, and they are sharing that openly. The largest one is the one with 70 billion parameters, and the rumor is they're building one with 400 billion parameters. And by the time that comes out, I need to upgrade my MacBook because it's not capable of running that. I frequently use these two when I'm doing something locally, or if there's a requirement that we cannot put stuff in the cloud. These two are super capable for that. Microsoft Phi 3, nice combination to any of these if you need faster results, faster summarization, but not that much reasoning for complex topics. And some other ones, I wanted to highlight Wizard LM2, which is almost equal to Llama 3 in terms of performance and capabilities. And they announced that about a month ago. I happen to be online, I click download, I'm hosting it, oh, this looks great. I point to my colleagues, oh, try this one out. They go, it's not available anymore. I was like, no, it was there online just an hour ago. No, but it's not anymore. And then there's a message, yeah, we had to pull out that from release because we forgot to censor all of the content that shouldn't be in a large language model. So you got the uncensored version. And I was like, well, this is great, I'm never leaving this. But now we got the censored version and all the fun stuff is away from there. Alrighty, a bit on security. Eurovision 2024. That is the reason why if you Google me, I am not on the front page anymore of Google. I used to be, I was a little bit proud of that. The reason for this is that Finland's participant to Eurovision 2024 in Sweden was a guy named Windows 95 Man, and the guy who did the lyrics happens to have the same name as me. So I've had people call me in the past weeks to ask for autographs and if I could do appearances at events. I'm like, yeah, I'll just leave you with this picture. And this is not the same person, sadly. So now if you need to Google me, click on the second page of Google and you will find me. One thing that we don't know how to build anymore, this is probably due to Azure, automating quite a bit of stuff, is an experience I had with a customer a couple of months ago. I was in a call. They said, well, Jussi, now that you're here in the call and you seem to be fairly knowledgeable about stuff, can you help us debug our locally hosted Windows file server cluster with DFS replicas integrated to Active Directory? I'm like, well, it's 2024. I did this last in 2012. Yeah, but you probably know this stuff by your heart. So let's just quickly hop into this one. And there's a guy who shares his screen. He has literally 8 RDP sessions, like in the Inception movies. He has 17 different MMC consoles running. He clicks through all of them and says, here's the problem, what do we do? I'm like, well, if you click on view and refresh, let's see if it's updated. And everything is red. He clicks view, refresh, everything becomes green. They're like, see, Jussi, we knew you know this stuff. It's fixed already. I'm like, yeah, I know my stuff for sure. Let's close this and let's not talk about this ever again. So Microsoft came up with the idea that wouldn't it be great if your Windows 11 took a screenshot every 2 seconds, stored that without encryption on your hard drive? Would that be great? Everybody goes, yes, that's great. So Windows Recall available starting in June for devices that meet certain criteria, meaning that they have to have the ARM silicon, the NPU chip in there, enough disk space and at least 16 gigs of RAM. It's an interesting aspect. I for sure will be working with my customers to disable this. There's a GPO already available in Windows Server 2025 where you can just flat out disable this unless you're the Darth Vader and you work as a manager and you want to capture everything your employees are doing, then do enable this. Otherwise, you want to keep this off. Couple of quick insights from Microsoft why security is hard. This is from the past winter. Microsoft surveyed their customers through their consultancy services to check what sort of challenges customers have. In secure Active Directory configuration, 43% of customers surveyed had insecure Active Directory configuration. Active Directory became available in December 1999, so 25 years ago roughly. And about half of the customers do not know how to configure it. Perhaps we need to move on. Perhaps we need to secure this somehow. So what they came out with was Copilot for Security, which means security meets AI. And Copilot for Security, if you're looking at this picture, it looks awfully the same as Copilot for Microsoft 365 because it's using exactly the same approach. They just changed the icons in here to make it look different. The idea is that it pulls all data from all of your central security systems like Microsoft Sentinel, Defender for Cloud, Microsoft Defender, and then you can do prompting to ask, do we have any problems we need to worry about? They came out with the concept of SCU, the Security Compute Unit, which is $4 an hour, and you need at least one. So bare minimum for Copilot for Security will cost you about $34,000 a year. This is bare minimum. For production use, the recommendation is 3 SCUs, which is of about 100,000 a year to do prompting. But if you're really serious, you go for 10 at least, which is $345,000. So what I want to quickly try, let's hop to my browser, let's reload the page. This is Copilot for Security. I can ask it to do all sorts of things. Make me a KQL query to find all Windows 11 24H2 devices. Let's do something like this. So it's thinking for a little bit, and it's firing up the plugins. This takes about a minute to do. And I'm running this with 1 SCU, so it's relatively slow. If you want to crank up the SCUs, you can go to Settings. Each SCU will bring you more cost. So if this is too slow, what you can do is you go to Owner Settings, and you come in here and say, I want more. If you go for 10, no, we don't allow that. You have to manually click it like this. And the estimated monthly cost is something. So what I want to achieve is more speed and performance. And I have fresh in mind the problems I had with costs and billing with Microsoft. So 100 is the most one. When you click Apply, it immediately charges the first hour. So $4 times 100, $400. Let's go with this. And please, somebody remind me after my session that you need to scale that back down. Otherwise, I need to sell my house. Is it any faster? Let's go in here. Let's open the old session. 49 seconds. Let's try again. Make it again. It's exactly as slow as it used to be. But at least we spent $400 on this nice experience. Alrighty, quickly, last before we wrap up, some advice I'd like to give to 20-year-old me. You don't need to do page numbers in PowerPoint slides. I see a lot of people doing this because they want to print the slides. Nobody prints those. If you have an email signature that says, think of the trees, don't print this, you don't need that signature either. And the last bit is, don't spend months and months in 1998 learning regular expressions. Generative AI will do it for you automatically. Lastly, on security, there's all sorts of great things you can do, but it all boils down to this. Deploy Defender XDR, which means endpoint protection. Deploy Defender for Cloud, the reasonable Sentinel deployment. You're better than 98% of deployments that I'm seeing when you just deploy these aspects. In closing, build a strong foundation to succeed with Azure and security and generative AI. Build at least 1 or 2 super deep dive areas where you want to be in. For me, those are security and utilizing Gen AI with infrastructure. Not probably being the developer for that, but utilizing those the best I can see. And fiddle with all the new previews and services in your home lab. We also had a requirement to have an ice bear, a polar bear in the presentations, so I hope I've achieved that requirement as well. Thank you, enjoy Iglooconf, and have a nice day.
We'll be having a roughly 4-minute break, so if you need to change the room, go outside from there, and then you can enter that room from the other door on that side. And Gert will be talking about platform engineering next.
Mohtuuko täältä? Pienet miehet. Lähemmä otan tästä. Totta kai. Is the sound also
Is the sound also working from my laptop?
Yeah, it should. Yeah, it should work. That's the previous one. It should work.
Yeah.
All right, welcome to the second presentation of the day. And without further ado, I will let Gert take over here. Let's give him a big hand.
So welcome everyone to this talk about platform engineering. I don't think the sound is actually working. It should play the Mario intro theme, but it's not. Should it be black magic, I think? Okay. Well, I thought a talk about platform engineering, platforms, platform games. Let's do a Mario-themed talk. But then yesterday at the speaker dinner, I heard we need to put an ice bear in every slide. I was like, how I'm gonna fit an ice bear into this? So I got to work, and it became quite late last night, but eventually I turned Mario into an ice bear. So today we're going to talk about platform engineering. I think it's quite a hyped term over the last couple of years, and it's what we do as an industry. We kind of break. We like to take some hip terms and then run with it and do weird things with it, right? So let me first introduce myself. My name is Geert van der Kruijsen. I'm from the Netherlands, and what I do is I work there as a principal consultant at a company called Cebia, and I help other companies build better software, and I do that through DevOps principles, cloud infrastructure, software architecture, and mostly the combination of those. And that's where platform engineering really comes into play. So let's take a look at platform engineering. As I said, it's quite a big hype. And if you look at some of the reports like Gartner, they predict that 80% of the large organizations will actually do some form of platform engineering by 2026. So show of hands, who is currently doing platform engineering or think they are doing platform engineering? Some hands, so still far from 80%. And of course, this goes about large organizations. You do need some form of scale to actually do platform engineering. Oh, now the sound works. So what I wanted to do is, before we get started and I talk about a lot of common mistakes that I've came across myself when building platform teams, doing platform engineering over the last 5 to 8 years with different customers, I wanted to check in with all of you and do some just some checks. So what are the current opinions that you have about platform engineering, using certain tools, etc.? So if you could scan this. Still see a lot of people scanning. So I see 48 people in, 50 already, so let's go. So I have a couple of questions that I just want to talk to you about, or check how you are currently thinking about that before I actually start doing the presentation and talk about all the mistakes that I've seen. So first of all, does your company do platform engineering? Yes, no, maybe a little bit? That's actually, when I did a show of hands, only a couple of hands go up, and now there's actually quite a large group. So it's good to see that this works better with the Finnish people. Okay, so we have well, quite a lot of people actually doing this, so that's good. Also, a lot of people sort of doing it, so that's hopefully that you can learn something from this this talk. How many people are in your company? So most of you working for smaller companies. You see, platform engineering really is a trend that's really big at the very large companies. That's where you have the scale to often do this. But it's good to see that's also happening at smaller companies. Have you ever worked in a platform engineering team, or are you a consumer? So most people are building it. Okay, let's keep going. So this is a bit broader question, like what kind of platform are you building? Is that like a cloud platform? Is it more of an application platform, security, CI/CD, networking? And it could be all kinds of platforms that you create. It's quite all over the place, no security yet, but yeah, it's typical to see most of the companies are actually investing in cloud infrastructure, cloud landing zones, those kind of areas, to make it easier for people to actually build stuff on the cloud. You see already talked about it in the previous presentation, where it can take quite some time for people to actually get going in using the cloud, for example. And platform teams can actually speed this up within your company. And for the people who work in such a platform team, how do you decide what is being built? Some people just take the first item from the backlog and start working on it, I see. So. Okay, this is a clear answer, so that's quite good. So a couple of more questions. Do you measure the use of your platform? Do you actually know who is using it, how they're using it, how often they are using it? Well, this is all over the place, so it's good to see that there are quite some people actually measuring this kind of stuff. This is a thing that I often see. I saw a lot of people are working on infrastructure as code. Does your company build reusable infrastructure as code templates? This is what I expected. We'll come back to this later on in the presentation. How do you expose your platform to your developers? Is that through a web portal or a ticket system like ServiceNow, or is it API or Git? Quite some people using Git. A few web portals being built. Okay. I think this is the last question. How do you actually build your current platform? So a lot of GitOps, some custom code, and some commercial tools. Okay. Okay, let's get back to the presentation. So platform engineering. As I said when I started this talk, the term platform engineering is already abused quite a lot because all of the different tool vendors like to build tools and sell tools, and of course, when a term like platform engineering is hyped, then of course your tool will also do platform engineering. And this is actually what makes it so that the term platform engineering is used for a lot of things. Well, the original idea of platform engineering and is basically this definition. Platform engineering is really a technology approach that can accelerate the delivery of applications and the pace at which they produce business value. So the key things here to remember is accelerate the delivery of business value. When I heard this the first time, I was like, we've been doing this for a long time, right? We've been doing DevOps. And if you look at the definition of DevOps by Donovan Brown, he said, DevOps is the union of people, processes, and products to enable continuous delivery of value to our end customers. So this is basically the same thing, right? We're enabling value. So is platform engineering the same as DevOps? Are they competitors? Are they going hand in hand? And I believe the last thing is actually true. I really believe that DevOps teams who build and run products from start to end build the best kind of software, the best kind of products. But the problem is that DevOps is kind of hard. In the last presentation, Jussi showed a graph of all the skills that he needed to know to actually build some software and run it in the cloud. If you have a team that runs and builds software from start to finish, you need to know a lot of things. You need to know about building the software itself, front end, back end, user experience, all those kind of things. You need to know how to deploy it. You need to know how to run or build the infrastructure, deploy the infrastructure. You need to know about CI/CD. You need to know about security, costs, all those kind of things. And it's just too hard. We don't have the capacity to do all that in a small team. So that's where platform engineering comes in, where we define certain services and provide those to our DevOps teams, so those DevOps teams can just take that from the shelf and then don't have to think about it anymore. See it as using platform as a service features from the cloud. Are you then not a DevOps team anymore if you're running such tools? You're still owning the actual implementation of the tools, except someone else is doing the hard work, heavy lifting of actually running the machines maybe in the back, right? So that's why I think DevOps and platform engineering really go hand in hand. But as I said, one of the big problems is our industry and hypes. And all of those hypes, they kind of destroy the thing that it was meant to be. So looking at hypes, one of the biggest hypes, right? AI. Everything is AI right now, right? I was walking in a store last weekend and I saw a vacuum cleaner with AI. I was like, what is this? So now everything is AI. And I think that's the same with platform engineering. So we need to get our industry and hypes, we need to do the things right. Same with Agile. We all do Agile development now, but I see so many companies still going in the dark for 12 to 24 months and then finally releasing something. Yeah, they built the thing in small sprints, but they weren't Agile. They had one idea up front and executed that in small pieces. That was not what Agile was about. And don't get me started about microservices, right? So microservices, yeah, everyone's doing microservices. All the tools can do microservices. And that's the same with platform engineering. A lot of the tool vendors now are jumping in the platform engineering space and then solving platform engineering by just selling you a tool. That's not how it works. So let's look at the first of the 5 issues that I see a lot when working with these platform engineering teams. I've set up a number of platform engineering teams at my customers, but I've also been on the on the other side of having to consume the products that platform engineering teams made at other customers. So what I often see is that these platform teams are often traditionally coming from more of the IT side of things instead of the developer side of things at companies. And what they do is they have the idea of, we just build something and then in the end everyone is going to use this, right? So I would like to call that the build it and they will come fallacy. They just build a platform and then expect that all the developers will love this product and it will make their life easier. I really don't believe that's true. I really believe that you should run your platform as a product, an optional product that developers can use if they like it, and if they don't like it, that they could just do it themselves. As I said, I believe in DevOps teams owning things from front to end, and if they choose to make their life easier by using your platform, then you actually get the right use of that platform. If they're forced onto that platform, or if they don't like how that platform works, you will run into all kinds of other things. And try to stay close how your developers actually want to use your platform. I already saw it in the poll, like how are you going to communicate with your developers, right? Do developers want web portals where they have to request all kinds of things? Or do they like things that are more close to their hearts, like a CLI, which they can just run from within the IDE, or using Git, which is the tool every developer knows and loves, and they don't have to make that much context switches from on one side going to this portal and then requesting some stuff and then going back to their code again. And when you're running your platform as a product, are you building the right features? Do you actually build the stuff that your developers need? So what I see happening a lot is people are building landing zones or building security platforms or application platforms. But are those the things that your developers are actually waiting for? I asked this question in the poll, who builds like blessed infrastructure templates? And I got like 95% of the people say they do. I really don't believe that this is something that developers are looking for. Because if you look at it, most of those templates, they, on one side, do not have all the requirements that different teams have. If you have to scale to, let's say, minimum of 10 teams, all of those 10 teams will have different requirements. They will need different parameters, etc. So if you build these kind of templates and force it on them, you will either be the bottleneck because they don't have the parameters that they expect you to be, or you create a really generic template that works for everyone, but then it's basically a template that does not add any value anymore. They can just take the original template that they build themselves that actually has their specific needs. So yeah, I often have this discussion, and you only have limited time, right? So build the stuff that really help your developers. But then people say to me, well, we do this for security and compliancy reasons. But is building templates actually the right use to do these kind of things? Of course, you could create a whole library of Terraform or Bicep that deploys these kind of things for you. But there's actually other stuff in Azure, like policies, that can check the right things for you, but you don't enforce the way you deploy it on those developers. So the developers themselves, the teams could decide themselves if they want to use Terraform or Bicep or use a CLI. You just define what should be the guardrails in which they should go. And on the other hand, if I look at those templates, and if they have a lot of parameters, and maybe I've seen teams also packaging them up into like build tasks that you can add to your pipeline, etc. Even more abstracting the infrastructure as code away for developers. I really don't understand what is the value add to that, because then you're adding another abstraction which a developer needs to learn. And they either need to learn the actual infrastructure as code, or they need to learn your abstraction, and they need to know about the actual infrastructure as code anyway, because they need to know how that product runs if they run the actual infrastructure themselves as DevOps teams, right? So they want to know about all the features that are in there. So abstracting that away for those teams is not really that valuable. And as I said, if you build these kind of templates, and also it also goes for all kinds of other platforms, when you build such a thing, try to build it in the open, so other developers, your customers, can actually contribute to it, so you don't become the bottleneck that much. So this is the first issue that I wanted to talk to you about. So we have 4 lives left. Let's continue to the second one. So when building these platform teams, as I see at a lot of companies, they're often originally created through from the IT department itself. So a lot of IT pros there, which are often quite disconnected with the developer community that they're servicing. So as I said, you want to build a product team. You're actually building an internal product, so you need to know about the demand that your developers need. And it's called platform engineering, right? So engineering means you're actually building something. So it's not only doing operations, it's not rebranding your operations team to a platform engineering team so it's cool and hip and it's easier to hire people then. Now, if you actually put up vacancies for platform engineering to hire new operations people, this will not work, right? They will see through it in the interviews and not come to work for you. So when setting up such a team, what I like to do is follow a principle from a book that's called Team Topologies. And Team Topologies, they originally created years ago something that was called DevOps topologies, where they described how DevOps should really work and how those Dev and Ops teams should work together or be combined. And in this book, Team Topologies, they talk about DevOps teams as stream-aligned teams. And these stream-aligned teams, they build business software from front to end. So they are responsible for a value stream within your company of delivering that business value from front to end. But as I said, that's really hard. You need to know a lot of things, and it's really hard for such a team to actually being able to execute on all those different areas. So in the book, what they've defined a number of other teams. On the bottom, it's the platform team. And this is where platform engineering comes in. The platform team delivers a number of products, services that other teams can consume. And the stream-aligned team itself, they are in control of what they want to use as a product, what they want to do themselves, and they can make those choices. Then on the other hand, there's some other teams, not really that relevant for this talk, but I want to add it anyways. The complicated subsystem team is a team like if your value stream is that complex, so let's say you have to build a very hard algorithm, you could have a team that focuses on that algorithm by itself because it's so complex, but it does not add business value by itself, that algorithm. But you could have a team that just packages that up and delivers it to the stream-aligned team so they can integrate it into their product. And then finally, the enabling team. What I see happening in practice is that this is often mixed with the platform engineering team as well, or just called platform team, where the platform either builds products, but also goes into stream-aligned teams to help them by doing like internal consultancy or skilling up the people, bringing knowledge into those teams to get them sped up. But these are actually two different things, and you could have two different teams for that. You can, of course, combine those kind of things, but you have to think about what are we building as a product and what are we doing for helping teams. And because if you do this all in one team, it's very easy to start spending all your time in enabling those teams by just helping them hands-on. But this does not really scale well. So when you're running a product team, building this internal product, you really need the skills to actually run a full software development product, right? So you need product management. You need engineers to build stuff. You need to build documentation, so the developers that you want to help actually know how to use your products. And maybe do some internal consultancy on how to use those products. But as I said, be careful with that on where to spend your time. I see a lot of people moving and spending so much time on doing that internal consultancy. That means that the onboarding, the documentation, etc., those kind of things are often lacking because you need so much work in actually helping those teams. And have a team that's really focused on one thing. Are you building your cloud platform to do cloud infrastructure? Are you focused on building a application platform? Maybe a Kubernetes-based platform where it's easier for people to run containers somewhere? Are you building an API platform? Maybe a FinOps platform so people can get insights into their cost, etc. These different areas need different specialization of people, so get the right people on board when building your team. So on to the third one already. This third one, enforcing it on your users is, I think, the biggest mistake that I see. It's just everyone falls for it. As I said, you want to enable your developers. If you push products onto your developers, you're not getting the best product because they have to work with it. But that does not make it into the best product. And we're living in a time where hiring developers is really hard. And non-happy developers will eventually leave your company and will go work somewhere else. If you build a platform and enforce that on your users, do you really think that will lead into the best platform that will make your developers happy? I don't think so. So I think building the stuff that your developers really need will actually work best, and then developers will also be happier to use it, to contribute to it, all those kind of things. And so really try to focus on empowering your users and not trying to enforce all the stuff on your users. When you try to, and I see this happening at so many companies, when you try to enforce it on users, developers and engineers, we're smart people, right? We will find ways not to use it and use our other products. You will get a lot of shadow IT happening within your company. So you enforce one product on your engineers, and then you will have 5 or 10 different ones running somewhere in the back that you don't have any knowledge of. So try to build something that your developers want to use. Try to find something that your developers are really bugged with. If they have to wait for have to wait for a long time to get things done, or if it takes a lot of effort, try to build solutions that really work for those kind of things. And what I see happening a lot when you enforce these kind of platforms is you get something that's called malicious compliance. So people will use it, but then every time when something goes wrong, yeah, we delivered our software too late. Yeah, that's because the platform did not work well. That's because we had to wait on the platform for this and that. You really get this you versus them approach, right? While I would opt for getting a good relationship with those developers, really helping them out, and then you don't get this blame game in between. And I understand that this can be quite hard because the traditional reflex is, yeah, we just need to do everything secure and compliant, so we need to enforce it on our users. But you can also tell those teams, well, you don't have to use it, but if you use it, then you are responsible for the security and compliancy and those kind of things. It's a small change, but this often makes it so that the teams will actually start using your platform because they don't want the extra burden of the security and compliance, etc., on their product. So let's go to the fourth one already. Not measuring. So when I checked before we actually started the presentation, I saw a lot of people are already measuring, which is really, really a good thing. But in practice, and I've seen so many of these teams already, is that measuring is not really happening that much, or not in the right ways. So when you invest in building a platform team, does that platform team actually deliver any value, or does it cost more than not running this platform? Do you actually get any return on investment on the time that you spend on building such a platform? Jussi said it in the initial presentation where he showed some picture of creating a cloud infrastructure landing zone enterprisey thing, which took 12 to 24 months to actually get that done. How much time and effort did that actually cost? And how much time does that save for the teams that you are enabling in the end? And are those the things that are blocking the developers the most? What I noticed in the poll that I did is almost no one was working on security platforms. When I work at large enterprises, security things are almost often the things that I have to wait on the most. Requesting firewall changes, network changes, all those kind of things. It's not uncommon that takes a couple of weeks for such a change to be executed, right? If you create self-service scenarios for those kind of things, that might actually really help your developers in making their life easier, while almost no one is actually investing in it. So let's look at how can we look at making measuring a bit better. Because in the end, when we're running our platform engineering team, our time is a zero-sum game, right? We only have X amount of time to work on stuff. So if we build one feature, we can't focus on the other. So try to spend your time wisely. Try to spend your time on the stuff that are blocking the developers the most. And instead of building really large platforms that does everything for your developers, try to build small things that can get going really fast, that can help your developers really fast, instead of building such a platform for 12 months and then enabling it for everyone. It can be very simple. It can be a very simple platform that only has one or two features if those features really help your developers. So try to know what your developers need. What are the things that are blocking them the most? And how do you actually know these kind of things? It's not that hard. You can start asking around in your company, like, what are the things that are blocking you the most for doing your actual work? Another thing you could do is things like value stream mapping. Look at the actual work that teams are doing, from having an initial idea of building this new business capability to deploying it to production. And what is the time that it takes, and where is the waste in that process? Are they waiting a long time to request a production environment? Are the pipelines really slow? What are the things that teams spend their time on? And can we accelerate that? Really try to find where those bottlenecks are, especially looking at several teams. What are the commonalities between those different teams, and how can we enable those? Another thing that I really like is measuring can be really, really rewarding, right? It's when you build such a platform, knowing how your platform is being used, how much time is being saved, is actually quite a nice thing to see and see that you actually delivered some value. So what we did at a customer is we created this self-service scenario, and it was enabling developers to do something that would normally take them 2 hours to do by themselves. So what we did is we just had a dashboard of that we ran in the room where we worked as a team. And we just had a small dashboard showing the number of times it was being used by developers. And we just added 2 hours saved for each time that the automation was run. So with that, we just had a dashboard that says, well, so many hours saved, which gives a really nice feedback loop into, oh, this was actually valuable. We saved so many hours of the developers that they would otherwise have to do themselves. And this really brought joy to the developers that were building the platform. Oh, we're actually adding value to these developers. So on to our last live. The last issue that I see a lot, and this is also because our industry and all the tool vendors, is that there is so much focus on tools. Tools are not that important. Of course, we need tools to get stuff done, but we can do a lot of things without spending so much time on tools. Especially if you look at the platform engineering space and you try to search for platform engineering tools, you will find one keyword popping up quite a lot, even more than AI, is Kubernetes, right? Kubernetes is all over the place, especially in the platform engineering space, because Kubernetes itself is really, really hard. So you need something like a platform to actually do this in a proper way. But do you really need Kubernetes to do platform engineering? Do you really need Kubernetes at all? I really beg to differ. Don't get me wrong. I really believe that Kubernetes has a number of features that are really, really valuable, especially for larger scale teams. But what I see happening is there are so many small teams taking up Kubernetes with all the extra labor that you need to do in running such a platform by itself, that it does not add up. It just try to come up with simpler solutions. And of course, the big hyperscalers see this as well, so you get solutions like they were just announced on build, like AKS Automatic, which is like Kubernetes with batteries included. So maybe times are changing a little bit, but really think twice in, do I need such platforms to do my platform engineering, or do I need such a platform at all, before you dive into it directly and start building all your tools on top of it. And what I think, and I saw it in the poll already, is that you already have a lot of tools, even maybe if you don't know it. And I saw a lot of people actually do know they have the right tools and do it in the right way. Because what I think, you already have tools like source control, Git, You already have CI/CD tools, pipelines, automations, etc. And this can be a really, really nice base to get your platform engineering team going. So this is an example of what we did at a customer who wanted to make it easier for teams to just request a new environment to start running their application. So they wanted to request a cloud subscription. They wanted to request an Azure DevOps project that goes with it, had all the connections already set up, etc. So you could just enter your code and deploy it straight away. So what we did is we created a central repository that was accessible by anyone. And people could just add a file like this, where they would request a number of things. So you could request a number of subscriptions. You could add a number of team members. You could have all kinds of additional settings, like do I also want Azure DevOps connected to it and all the service connections already made towards these subscriptions. And by entering this file, everyone could just do this, create a pull request. We would have some automation that would check if the file was valid. And if it was valid, an automation would run, and all the stuff would be created for them. So a couple of minutes later, they would have their Azure subscription, their Azure DevOps project, the service connections. If they were running Terraform, all the stuff for storing your state would be already there. Like creating something with batteries included so they could just get going. And we didn't have to install any tools for this. We didn't want to be the police agent before anyone would request these kind of scenarios. So what we did is, if you would add team members, we would create a pull request and we would actually ask the existing team members for approval. And the nice thing is, if you store all this in Git, you already have your audit trail of who did what changes, and when were these changes made. So you have a full history of all the things that happened to your team, and all the changes that were made through history. So if you start building a platform, use tools like this instead of buying stuff commercially off the shelf. As I said, Git really, really works well. Then another tool, I'm curious, a show of hands. Backstage is like taking over the industry as a storm. Like, who is using Backstage for their development portal? Only a couple of hands. Okay, Backstage it's quite a nice tool built by Spotify, which is an open source tool that gives you insights into all kinds of things and also enables some self-service for you. So it's really easy to hook up your cloud environment, your CI/CD tools, all kinds of things, and get one view of your whole landscape, which sounds nice, but when I see this in practice, it's like the one pane of glass promise. Of course, that they promise, right? But I've read this quote, and it always sticks to me when I see Backstage being used at customers. If you put a pane of glass over a piece of shit, you still see the shit that you created, right? So, yeah, Backstage can be a really useful tool, but don't try to make it the one tool that solves all your problems. Make it really specific to maybe find certain things, because that's the thing that we run into often. Make sure that the developers who want to use your tools actually know how to use them tools and how to find where they can use the tools. And when you're building a platform, and that's also why I like Git and those kind of tools, because then authentication and signing on, etc., is already fixed for you. If you're building a portal, please, if you're building a portal, and in some cases this might be a good solution, make sure that you have things like single sign-on enabled, etc. Just to make the life of those developers easier. And think about when you're building platforms like this, security is really key, right? If you're if you make mistakes here, your mistakes scale out through all of the teams, because your platform has access to all of the different teams. So make sure security is always one of the key aspects that you that you focus on. It's hard to bolt that later on. So do that from the beginning in the right way. Oh. That was not, my laptop was a bit slow. So lastly, you can't do a conference talk nowadays without mentioning the other hype, AI. What I see is that a lot of teams are struggling with doing AI. How do I enable an AI in such a way that I have the right guardrails, etc., to use? So building a platform for teams to enable AI is also quite a new kind of platform that you could try to build, especially if you're working with a lot of sensitive data and those kind of things, making sure that you give teams the tools to do this in a proper way, instead of seeing all this shadow IT happening and people using all kind of tools that are out there on the internet that they can use for free. And they can use it for free because they're not the consumers, but they're part of the product, right? So think about this. If you want to enable your developers with AI, this could also be one of the features that you build as a platform team. So with that, actually came to the end. Small recap of the 5 things that I see happening at a lot of companies and how to try to avoid it. Really try to focus on your customer needs. Try to focus on what those developers actually need, and build a team that is capable of building and running such a full service. Try not to enforce it on your users. Make it so that developers want to use the product. Try to measure that you're actually doing the right things. And try not to focus too much on tools in the beginning. If you Google platform engineering, the first couple of pages will all be full of vendors trying to sell you platform engineering with one tool which does not work out of the box. So with that, I would like to thank you very much. On to lunch.
Thank you. Thank you. So the lunch is probably starting at 11. So if you guys have any questions to get, maybe we can take a couple.
Yeah, we have time for questions.
Anybody? Questions? All right.
I'll be around today and part of tomorrow, so if you have any questions, you can always drop by in the hallway.
Yeah. All right. Thanks, everybody. Lunch is until 12 o'clock, so meet you back here at that point. Thank you. All right, welcome back to our third presentation today. And without further ado, let's bring Henry to the stage here to tell us about Bicep. With a big hand.
Hey, good afternoon, everyone. So what's new with Bicep? Well, the answer is a lot, kind of depending on how far you go back. But I think if you look like 12 to 18 months back, there are quite a lot of new things that are happening in the infrastructure as code space in Azure that we're going to be talking about today. Now, before I dive in, I have an important question. Who here has experience with Bicep? Fantastic. Who doesn't? And I'm not going to ridicule you, but I'm not going to do like the 101. So I hope you can tag along, and if you really have any questions, just heckle and shout, which is apparently the general tradition here at Iglooconf. Feel free to ask questions, but I'm going to step over the basics. Who am I? I'm Henry. And there's a lot of stuff I do. One thing that I want to point out is that I created a new course on infrastructure as code for Azure on Pluralsight. Now, if you're not a Pluralsight subscriber and you do want to watch the course, come find me and I'll hook you up with a trial code, which should last you 30 days, which should be enough to watch the course. I mean, you go to conferences to get free shit, right? Well, this is free shit. Come find me. And I also wanted to share something about myself, and not my very short, non-impressive career, but something that is defining for my life. This is my house 2 years ago. We bought a very, very ugly, terrible house at a fantastic location 3.5 years ago. And we had a contractor in for 2 months, and this is what he got to at that point. So this is the worst that has happened to me in those 2.5 years, was the bottom line. And from there on, it got worse. Half of the wall at the back was removed. But from there on, it slowly started getting better. It's a very special house. It's a Dutch-style house. We call it a stolp, which means that except from the walls, everything leans on 4 poles in the center of the house. Everything was taken out, and here you see the first part of a new bit of house being moved in by the contractor. So the contractor put in 4 rooms like that, and then he left. And not because he wanted to, but because I kicked him out. And I said, I will finish this myself. So this is my attic. 2 months ago, after me spending a couple of weeks isolating everything and almost being done putting plastic in. And this is the picture that I took last week. So I'm now slowly building my own house from top to bottom. So I thought that's maybe something interesting about me, not technical. So back to technology. What is new with Bicep? Quite a lot. And I thought about how to go about this talk, and I thought, let's try to not make it a talk. What I'm going to do is I'm going to go over a number of things that are new, very quickly discuss them, hopefully within a couple of minutes, and then turn over to you and ask, what do you want to see, or maybe what do you want to build together? So if you don't say anything, or you say Kubernetes, this is going to be a very short session, but if there are things that you want to do together in Bicep, possibly with the things that we talked about, we can do that until we're kicked out of the room to make room for the next presenter. This is the question that I tried to start with. Of course, nobody loves PowerPoint, but unfortunately that's a screenshot. What we're going to be talking about is, I'm going to start with something awesome that was released about a week and a half ago, which is support for accessing Entra ID through Bicep. And if you're a Bicep user, this is probably one of the things that you have been waiting for. And then the other things that I can talk to you about are parameters. In Bicep, for quite a while, we didn't have Bicep parameter files. We still had to create those horrific JSON thingies and then combine them with the Bicep file. There's something better now. If you haven't seen it yet, I can show you. And we now have support for user-defined types, which allow you to create your own complex types. For example, 2 strings that have a meaningful name, or a Boolean and a string, something to enable a feature and to name it. We can take a look at how that works and also at how you can share that between multiple files by exporting or importing those types. There is a bicep config JSON file. I don't know why that's still JSON, but it's in JSON. We can talk about that and see how you can play with the linter, increase some warnings into errors, or maybe silence some warnings. Then there is another thing that's currently in preview, so that hasn't been GA'd yet, and that's support for resource-typed parameters and outputs. So if you're creating complex infrastructures where you're creating a resource in one file and then want to reuse it in another one, in the past you would probably pass along and the name and the ID and maybe 1 or 2 properties of that resource you just created. Now you can just pass along the complete resource. We can take a look at how that worked. And then there are 3 other things for which I had diagrams, which is what the asterisk is for, just a reminder for myself. And one thing that we can talk about is the Bicep registry. And what this allows you to do is, instead of taking your template and publishing it into Azure to create resources, is to publish the template itself. And that Bicep registry is nothing but a repurposed Azure Container Registry. So you create an Azure Container Registry, push your templates in there, and then other people who write another Bicep template can reference that template in the registry and reuse it in their own template to create Azure resources. Another way for creating and publishing templates is by deploying them as a template spec. So template spec is a little bit different than a Bicep registry because the template spec is a resource in itself in Azure. It's something that you see in the portal instead of it being hidden in an Azure Container Registry. So you can publish a template as a template spec, and then you can go into the portal, for reasons unknown to me, and directly from the portal deploy that template to create Azure resources. But of course, the other thing you can do is you can reference that template spec from another Bicep template and then reuse that from a central location to create Azure resources. So two different technologies that solve very similar problems. The third thing that was recently GA'd is deployment stacks. Now, let me start with a problem. If you have been using templates in Azure for a while, you've probably run into the problem that a template will help you create new resources. It will help you remediate configuration drift by resetting properties to the properties defined in your template after some person went into the portal and changed them out of the infrastructure as code. But what it didn't do was clean up resources or remove resources. And if your memory goes back even further, you might say, well, that's not completely true, Henry, because we also have something called complete deployment mode, which would remove resources in a resource group you're deploying a template to if they're not defined in your template. That was a hot mess, because a lot of resource types weren't actually removed by a complete deployment. I gave you alert rules, for example. Another problem was, what if two persons deployed to the same resource group using different templates, and then one of them starts using complete mode? They would evict all the resources from the other entry point. Deployment stacks are the solution to that problem. A deployment stack is another grouping mechanism in Azure that allows you to draw a line around a group of resources and group it together as a stack. And that's a terminology you will also see in other technologies like, for example, Pulumi or AWS CloudFormation. And what you say is, hey, whenever I redeploy this stack, I want you to create resources, update resources, but also think about how to remove resources from Azure that are no longer in my template. So let's assume we have an empty Azure environment, and we're going to deploy a template using an app service and a SQL database. And we make that a stack. Then we get this line around those resources in Azure. But what if we already have a resource in Azure and then deploy the same template as a stack? The outcome would be the same, because we're still creating or updating resources. But now it gets interesting. What if we have 3 resources in Azure in that stack, including the resource type that I hate the most, a virtual machine? So we're going to deploy a new template again with that app service and the SQL database. And what will happen now is that the stack will be shrunk to only encapsulate those two resources, and the virtual machine is shown as what is called a detached resource. We can now go into the portal, we can now go into the Azure CLI or APIs and find detached resources and consider them for removing. So this is more like a soft delete or a mark for deletion scenario. Another thing you can do with a stack deployment is add a flag called -delete resources. And yes, this does what you expect it to do. It will look at the template that you're deploying, at the current state of your stack, and if there are resources not in your template, but in your stack, it will remove them, both from your stack and from Azure. And this is a way for having controlled deletions in Azure, because it will not mess with your complete deployment scope, the resource group. It will only mess with the resources that you have declared to be part of your stack earlier. Another thing that you can do with deployment stacks is that you can lock the stack against changes. So for example, you can say nobody can change this stack except this one principle, which of course is your deployment pipeline principle of identity. This is the combination of template stacks and deployment stacks is positioned as the replacement of Azure blueprints. If you're using infrastructure as code to create maybe a landing zone or an enterprise a COF implementation, you're now using blueprints. They have been in preview for 25,000 years or so. They will not see general availability. They will stay in preview until they are deprecated. Actually, I think they're already officially deprecated, or at least notice is given that they're going to be replaced by template specs in combination with deployment stacks. And a scenario here that you might use is for example, from hey, we are an application team and we're deploying an app service with a SQL DB, and we want to connect that to the central virtual network because we need to access a resource from somebody else. So what you're going to do, you're going to create private endpoints to those resources, experience all the joys that Rick talked about earlier. and then connect that to a virtual network of your own. And then you want to pair that virtual network in that application resource group with the central network. Now the central team probably wants to take control of that virtual network and some resources around it. Because if you make a screw up there, it's going to impact not only your own application, but also other applications or services connected to that central network. So this is a way for a central team to deploy decentral virtual networks, spokes, and lock them against unwanted changes by application teams, but still allowing them to connect devices to them. The final thing that has more recently become available is user-defined functions. It's not a very large feature, but if you do a lot of string manipulation in templates, it can be a very handy trick. Now, not listed here, and for everyone watching this screen, what I'm going to share now is part of my Pluralsight training. I can use that here, if I mention that. So what I also have is a more elaborate bicep demo where I deploy a central network, a decentral spokes, a routing table. So a bit of a larger example that we can walk through if you want to get some feeling for how a larger example would look like. So, what do you want to do? User-defined types? Yeah. All right, one nomination for user-defined types. Anyone else?
Deployment stacks, some examples of those.
Deployment stacks, all right. Anything else? So I'm not going to open a GitHub repository and going to work together with you, but feel free to join in, point out mistakes I make. I'm just going to try and make this work together with you.
Maybe template specs as well as an example how it shows up in the portal and like how can you reuse it.
All right, so user-defined types, template specs, and deployment stacks. Should be able to fit that in. Anything else? You're all familiar with parameter files? Okay, cool. If you're not, look them up. I find them a very nice, convenient addition. All right. Let's do something ridiculous. Open a new screen. And create a new file. And let's call it, say, temp polarbear.bicep. Now I'm going to quickly bring something over to make sure you don't watch me typing all the time. I'm going to bring over a app service plan containing an app service and some configuration. So this should be a valid file. Let's make it, let's say setting 1 is awesome value. And then, of course, enable more awesome stuff is false. Nobody likes awesome stuff. And let's say var location is resource group. That's location. This should be a valid template, I think. Now, the problem that we are seeing here, at least I find the problem, is that we're going to build a collection of key values that contains the configuration for my app service. And of course, this list can grow over time. So something else is added here as well. And now some kind of thing starts happening that instead of providing the values here, we're going to say something like sdfkj value. And we want to take that as a parameter to this template. And we're going to say param enable awesome feature, which is going to be a Boolean. And then we're going to use this value here. And in any real world application, this can quickly grow to 10 or 20 values. Now, of course, putting all those values there, declaring them as a parameter, in a calling file, adding them as a value to the module deployment and maybe 2 or 3 layers deep is very annoying. So what will a developer do? It will say, well, you know what? This is an properties value, It's going to create one. This is what I see a lot of engineers do in practice. Because this makes it much easier. They don't have to type as much. And they know which settings go into that object when they create the outer template. Right? Everybody following along with that reasoning? Yeah, so that reasoning sucks. Because somebody else comes in after that genius developer and he's like, what are valid properties on the configuration object? They don't know because they didn't create the API. They just have to expand upon it. The problem is that object is pretty untyped. So we're going to create our own type. And we're going to say my app service configuration type is going to, well, we have, of course, awesome feature enabled, which should be a Boolean, and we have the SDKD value, which should be a string. And now we can say, hey, instead of this being an object, we can make this of type my app service configuration type. Now, this postfix type is not mandatory. Actually, I don't really like adding what something is to the name of the variable, but what it allows me to do is this, because they share a namespace. And now all of a sudden, I have a typed declaration of the properties that go as a parameter into this template. So if I now create a new file, and I call that polarbeer.parameters.bicep, see how I'm sneaking in parameter files. I can reference just kidding. We're going to call it temp/polarbeer.bicep param. Sorry, that was a JSON reflex coming up. And now I can say, hey, I'm going to provide values for this bicep file, polarbeer.bicep. And it's going to say, hey, there are errors here, because there are mandatory parameters that you didn't specify. And as you expect from any cool editor, it can generate those entries for me. And here, I now have to specify the value for that object. However, I don't, well, actually, I'm already getting auto-completion, which is nice. So let's call this true, and let's give this the name awesome feature. So this now I have declared a type, I get tab completion, and if I transform this by accident into a string, I get error. So I've added type safety to my parameter objects. Now one of the things that you might want to do is share these definitions between files. That's not possible by default, but there is a keyword that you can add, or an annotation I should say, which is called @export, which exports the type, which is a syntax that you might know from TypeScript. And I can now create another bicep file with an even better name. And I can now say import star. Let's make it more precise. Let's import my app service configuration type from polarbeer.bicep. And now I can make a parameter of that type here as well. So you can create a bicep file with all your type definitions, if that's what's working for you, and then reuse that across your different files. That's user-defined types. Questions? Thoughts? Who thinks this is a valuable addition? Okay. Who thinks object is fine? I'm the only developer in the team. Okay. Well, I've had a lot of discussions with engineers that didn't understand the problem of untyped resources because they, well, we frankly didn't agree.
If you wouldn't have this feature, how would you implement it not using the object?
So what I do is the only way for this to have type safety and transfer meaning to the person that has to provide the parameter values is by listing them separately. And then, for example, you can do some smart things with namespacing, like, I don't know, app service configuration, dash setting 1, dash setting 2. But the consequence, of course, doing something with dashes or even dots is that you will have to quote the keys in the configuration. So it doesn't get prettier, but I do have to transfer meaning and context around the values that have to be provided to the person that's providing the parameter values. So this is a great addition. And in the latest versions of Bicep, this is now generally available. So I didn't have to enable any experimental feature. Some people might not know, but the Bicep executable doesn't upgrade automatically. So you have to AZ Bicep upgrade every now and then manually to get the latest version. Pro tip, saving you 4 minutes right now, also do it on your build server. Learned that the hard way. Any questions? Template specs? I'm here for I'm here to give you what you want. That is what I'm trying to achieve with this approach. So feel free to shout and ask questions. So we have declared this template. Template specs are actually still in JSON, not in Bicep. So to avoid a blamage of myself on stage, I'm going to remove the custom type because I don't think that works yet with template specs. Oh, Henry. So this is again a valid template. So what we now can do is we can say AZ, TS, and then I don't know anymore. So we can add help, then AZ, TS, and then it is create. We're going to create a template spec. We're going to create it in the resource group Polar Bear. And we're going to give it a name Polar Bear template. And we also need to give it a version which is going to be 1.0. And of course this is not going to work, so we're going to do AZ group create -- resource group Polar Bear -- location West Europe. All right, what did I mess up? Required properties are missing from object properties. I've never seen this error before. Invalid schema. Maybe I need to add something like template file and then the file that we're going to publish. This is a thing that I noticed a lot with the latest additions to template spec, deployment stacks, and also Bicep, is that you get the weirdest of errors. Because I would expect a meaningful error saying, hey, you stupid, you forgot to indicate which file you wanted to add. But of course, I should have known that invalid schema means that. Now we can now go into Azure. Let me make that a little bit bigger for you. And find our newly created resource group. And here's the template spec as a resource. So that's the thing that somebody asked to see. I can now navigate to the details of this template spec. And you saw me add a -- version. So I can have multiple versions within the same template spec. It says what's the latest version. I can go to versions, and then I can see the list. One thing that I can now do is I can go here and say deploy. And then I can deploy the template spec directly from the portal. So I've given quite some thought to valid use cases for deploying something using infrastructure as code and then deploying it from the portal. And I think I found one. You have a team of data analysts or data engineers that sometimes need things like Databricks or databases provisioned, but they're not really into Azure infrastructure. This is a way for you to write a template that you publish as a spec, and then they can deploy it themselves from the portal. I just made that scenario up, but I can see this working. And of course, there are similar personas as data engineers. Now, if we're talking about template specs, another thing that I can do is I can create a new template and say something like var is whatever. Save this as temp, and of course this is demo 3 by now. And I can now say, I'm going to add a module. And the symbolic name for this is, of course, module 1. And then instead of referencing a file, I can reference a template spec. And the syntax for this one is quite complicated, so I hope you forgive me that I'm going to look that up. Right here, because it needs to be TS :subscription ID / resource group name, which was polar bear. And then the name of our spec. Which was polar bear template. And then I think the version has to be a colon again. Now comes something cool. No, not that. Ta-da! In the background, it pulled the template from Azure because my logged in credentials have access to the template. It parsed it, it found the parameters for this file, and it generates the outline for deploying this thing for me. And of course, if I don't provide an object here, but a string, it will tell me again, I'm an idiot. So this is one way for reusing templates as a template spec. Does that show you everything you wanted to see?
Would you organize the specs in like one resource group, all the specs, or where do they meet? Because it's kind of resources or something, then somewhere that library of like and so on. So it's like still as a resource. There is a way how you organize it, where you say central subscription, where everything lives in your platform.
It depends. That's a bit of a naughty answer. If I, for example, create a template spec that I want to use to deploy landing zones, and I have like 5 or 6 templates with variations on the landing zone, I would put them in my management subscription in a specific resource group that only the platform team can access. But if I am creating blessed templates that Geert talked about as well, which I share a vision about with him, I don't really believe in a central team pushing out templates that are basically just templates wrapped around templates and adding a lot of abstraction and complexity without really adding value. Then I would put them in a resource group again in the management subscription and probably fix something with RBAC assignments to make sure that everybody can read those. If you create them for a specific team or a specific business unit, I would push it out to their subscription. But I really see this working if a team has to do a lot of infrastructure and they want to build a repository for themselves and they don't want to do it in Git. And then it's probably just a resource group of your own. So that's some considerations. But it really depends on your context and your individual configuration of your Azure environment.
So what do you see as main differences between private registry and template specs and maybe main use cases for both? And just as a protocol compared to, let's say, deployment environments.
Okay, so the question is, how would I contrast the bicep registry with template specs? So a template spec is a resource in itself, which means that if I go into the portal, it has its very own identity and access control entries. So I can assign very specific RBAC assignments on individual specs if I really fancy managing all those individual RBAC assignments. On the spec level, well, let's try something new. Well, what do you know? Even on the version level. So, and what would that enable for you is if you want to deprecate something in a larger organization, you say, well, this is deprecated, and everybody would say, mm-hmm. And nothing happens. But the first thing you can do when something is deprecated, remove access to it from everybody who isn't using it yet, and then try to slowly strangle that usage. So that's the thing that you can do with individual RBAC assignments. In the bicep registry, you are relying on the internal authentication properties of that registry, which to the best of my knowledge, because I don't do anything with containers, is non-existent. But that's on a very limited knowledge of the container registry. So the alternative is deployment environments. And you're probably not referencing to the thing in Azure DevOps environments, but the thing in Azure. I've never used it.
It's pretty horrible.
Sorry?
It is pretty horrible.
I would never say such a thing.
It's again,
Without taking a look first.
it's one of those overlapping services that does some of the same things.
I think we had dev test labs, which didn't really take off. Out of curiosity, who is using code spaces? Who has ever, okay, so one person, awesome. Who has ever tried it? Okay, why didn't you use it? No reason to? Okay, no reason to. Anybody who said, well, that's a very expensive replacement of my desktop? Because that's the thing that I hear a lot. I don't really see all of these things taking off in my very limited environment, honestly. So contrasting it, deployment environment, don't use them, personally. I would shy away from both, probably. I am a firm believer in per application having your own set of bicep templates and not sharing too much. And what I've seen working very well between a number of applications is just copy-pasting the templates out. And the big benefit there is that both sets of templates can evolve individually for the individual application needs. The one-size-fits-all approach doesn't really work if you really want to iterate on your application infrastructures, in my opinion. The only counterexample that I can think of is the virtual machine. If you still deploy a lot of virtual machines, it makes sense to have a template that deploys the extension for joining it to domain, the extension for enabling AAD logins, the extension for enabling DSC, some DSC stuff. That's one of the templates that I see actually having so much length compared to the amount of parameters that really adds value. That's some random thoughts. Hope that helps.
So with the template spec, that's a resource itself, so you deploy some. So with the template spec, because it's kind of resource, so that you will otherwise deploy with a bicep as well. So what's like, do you need CI/CD that will connect and push it, because you run the command manually? So you will need like pipeline for it most probably. If it will go to the registry, you will have CI/CD pushing it somewhere like ACR versioning and so on. So what will be the like life cycle management for this one, and how would you actually run it? Would you run a bicep to push this to the like Azure, or the AZ command is the only option actually there, because it's a resource in a way, it's infra resource?
And then your stance is we don't deploy it from the local machine, we want to go through pipelines.
Yeah. So like do you have any like, do you know what will be the good practice? I mean, it's a new thing, maybe it's not established, maybe the way to push it using AZ command, but
I would write a bicep template to deploy that the template spec. But what I've seen teams do more and more is that they actually don't use the tasks, but use the CLI from within their pipeline. And I even see them do things like ./build.ps1, because then they can really do the same thing on their local machine as they do on the build server. So I see them fewer and fewer using the very specific tasks that are created for Azure DevOps and probably also for GitHub Actions, but instead just build a .ps1 that contains the Azure CLI commands. There's also just a one-liner for doing a zip deployment. And the cool thing for them is that if they want to debug their pipeline, they can do it on a local machine, and their feedback cycle is way shorter. And I do have feelings about that, but it's probably, I'm a bit shy to admit it, I'm linking on to something that I've learned a couple of years ago, because I do see them iterating faster on their pipelines that way.
And if you have something deployed with like version 1.0, for example, and then is there a possibility to upgrade to version 1.1 somehow, or like those are just?
No, there is no automatic increment, because if I redeploy this again, I will get a warning saying, hey, you're going to override an existing version. Is that what you want to do? And of course, I'm very confident I don't make any breaking changes, so I'm going to say yes. But generally, you probably want to increment it yourself. But if you have that PowerShell file, which executes that ASE command, it's just another infrastructure as code thingy, but now not in Bicep, but in PowerShell. That's what I've seen. And I don't see a lot of template specs in practice, honestly.
Thanks.
Any other thoughts?
One cool trick you can do is remove your CI/CD pipeline permissions from those template specs. Then when a cache expires, you'll have a great time troubleshooting what went wrong, because it expires later than the permissions actually do.
Sorry, can you repeat that? I didn't catch
Yeah, so
that.
if you remove permissions to template specs from your CI/CD pipeline, the troubleshooting time you will spend on making it work again is fun, because the cache of the template spec load expires at some point other than when you remove the permissions. So be careful with that.
Okay, so I'll actually use the mic so I don't have to repeat the comment. Thank you. Shall we move to deployment stacks? Okay. Here I have prepared an example. So what did I do? I create a fantastic demo template, this time not using an app service, but for variation, a storage account. And what I'm going to do is I am going to AZ group create -- location West Europe -- name Iglooconf. I'm going to have a great time tomorrow cleaning everything up. And now I can say AZ stack create. My name is going to be demo stack. In that resource group Iglooconf. And my template is 07 deployment stacks demo.bicep. And I'm going to say deny settings mode is none. So what this is doing, it's going to create the stack for me. And as you can see, that's not working. But I can create is misspelled. AZ stack create. Create. Seems okay to me. Why? Oh, why? Oh. Because we're going to create a stack at the resource group level. And what's the mistake now? Oh, template. This is always the point that I hope that I'm not the only one who always has to go back and forth between -- help and documentation for finding the correct parameters. But we're finally deploying our stack. So we're creating a stack with the name demo stack. So this is the virtual line around the resources. In this case, just the storage account. And for the remainder, it looks a lot like the regular deployment command that we know from AZ deployment group create. And the other thing that differs is the deny settings mode. This is about locking of the stack deployment. In this case, I'm not locking it because that's very handy when you're giving demos. But here I can, for example, say lock against deletion or lock against update and deletion. And then there is another parameter that I can use to specify exceptions, which is where you would put in your service principle that you use from your pipeline. If we now go back to the portal, to resource groups, refresh that list, go to Iglooconf, and here we have the storage account. So this is nothing different. But I can now go to deployment stacks, and what I see here, hey, there is one stack called demo stack, so there can be multiple in a single resource group. And in that stack, we see a single resource with that fantastic name. If I now go back to my demo and I make this name even more fantastic, and by adding a 2, and I'm redeploying, it's going to say, hey, you might detach resources and resource groups because this is not the first time you're deploying this stack. And of course, confident as I am, I press yes. And only now I'm going to ask, who wants to predict what is going to happen?
There will be 2
spot on. So we will have 2 resources in Azure, one with the legendary name and one with the legendary name too. And if we go to the stack, we will see that the second resource is now in the stack and that the first resource is in the list of detached resources. And that list will always show the resources that are detached in the latest deployment. Of course, this is taking a while. So let's go back to the portal. Let's see if we can refresh the details of our resource group yet. Oh, there you go. The second resource group is added. And if I now go to my deployment stack, demo stack, and refresh that, here the predicted outcome. We can see that the new account is part of the stack, but the old account is detached. So what do? We go back to Visual Studio Code, we update this to a C, and then redeploy. Confidently press yes. Anybody want to launch a prediction on what we're going to see?
Everything detached.
Everything detached. Okay, based on what? What's your reasoning? What we will hopefully see is that we in the stack now have storage account C, ending in C. We have no detached resources because there are no resources detached in this latest deployment. And we will see that number 2 is removed both from the stack and from Azure. If, and only if, when you're giving a demo, you don't forget to add -delete resources. So that's not what we're going to see. And now I can't abort this deployment because it's just going to continue in the background. So we have to wait for a few seconds for this to complete.
Without that delete, then wouldn't it do the reverse? You would put first in this kind of state, but then detach them.
Yes. So we will get 3 storage accounts in Azure. We will get the second one in detached state and the third one enlisted in the stack. So what this does show is that once resources are detached, it doesn't retain them as detached for all the time. Okay, now let's now update this to a 4 and add top of mind. It's probably like this.
What's the use cases where you would not like to run delete resources?
If you, sorry, 1 second please, -- delete - resource, -- delete - what is, yes, there we go. So the question is, when do you don't want to remove resources but just detach them? If you want to avoid mistakes. So if you're in a company where everything is done through infrastructure as code, you're pretty and you have your identity and access management in order, you can be confident that nobody went into the portal and changed the setting or added the resources or otherwise was a person that didn't follow the guidelines. But if you are, as an organization or a team, transitioning from traditionally managing stuff in the portal to infrastructure as code, and some engineer just created a database with very important information a couple of weeks ago, and by accident it isn't in the stack yet, and because deployments are idempotent, you want to avoid that database getting removed by accident. Of course, you can guard against that by logs, but when you're in that transition, I can imagine that you want to make sure that you don't make mistakes. One thing that I've asked the team is if we can get an extra property on every resource is part of stack. Because then, as an architect or an engineer in the team, I can query for all the resources that are not part of a stack. So I use it as like an intermediate state where I know I'm going to delete them, but I just want to look at that myself before it actually happens. So that's the scenario that I see. And I think we are all willing to admit that we sometimes have executed a CLI command without the proper flags. So I think this is a real scenario.
Is there a way to do kind of alerting on those detached resources appearing? Because following up this scenario you described, natural consequence would be, yeah, I forget to add it to
Yes, but to make that possible, there are two ways. The one that I would love is a extra property on the resource. It's part of stack, and that property also being null, so like not part of a stack. I talked to the deployments team about that, and the answer is very difficult, and that translates to not going to happen, but not going to say that, frankly. The other option is that you can use the graph, the Azure resource graph, to query all deployments and all stack deployments, and you should be able to find all resources that are detached in the latest deployment. But you
I think I can have it as a follow-up job in the deployment pipeline.
yeah. And you have to run that frequently enough to make sure that there are no 2 consecutive deployments, because the detached state in that stack of the list of detached resources in that stack is going to not retain that resource between deployments.
Well, I guess probably the easiest way to achieve that is to actually have it as a step of the deployment pipeline, as a verification, and if that returns something, that simply block further deployments until it's resolved.
Yes, you need to remove parallelism as well. I still like that property on the resource itself, so I can just give me all resources that match this condition. Probably not going to happen.
Actually, can you, is it shown in Azure Monitor or like in telemetry monitor that you have detached resources? Because I would like to see them in log analytics.
That is a very good question. Let's find out together. So this is my resource group that we have been messing with. So I go to the activity log. It can take a couple of minutes for entries to show up here, but maybe we are lucky enough. I wrote a deployment stack. Right, great. And then, of course, we get into this. Oh, today I have to just click the line. Dun, 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 dun. Message. So I definitely can find writes to deployment stacks, and then because the stack deployment is a resource in itself, which is retained, I think, for 800 times as well, just as a regular deployment. You have a resource ID that you can at least query for a while, so that's one way. But then you have that indirection, which is not cool. But I don't think I see the individual detachments here, because I only see delete storage account. We can dive deeper into that later, but I think it's a very niche question, maybe not spend 10 minutes on with the whole group, unless everybody wants to see this. But I think it's not there.
It's not something that I need as a developer, but our operation team, they would like to see that one.
Yeah, because in most organizations, a lot of Azure spend can be saved by just removing stuff you don't need anymore. Is there anything else you want to see, or do, or talk about? Shout, heckle, sing, dance.
One clarifying question. The
Yes.
deployment stack, they are resource group specific, so you can't target deployment across multiple resource groups?
The question is, can you target multiple resource groups? Yes. There is support for deploying a stack, for example, at the subscription level to create resource groups and make that resource group part of the stack as well. That comes with its own individual problems, because now I create a resource group which is part of a stack, so that's going to be removed when I remove it from the stack. But somebody else comes in from the side and deploys 2 new resources in that resource group. What to do with those resources? They are not part of the stack, but they are nested in an entity that's part of the stack. So there is another flag, which is -- delete resource groups, which you can use to say, hey, I really want to remove the resource groups part of this stack, even if there are resources in there. And you can also deploy them at the subscription level. So if you're with that cloud adoption framework, enterprise scale in the back of your mind, yes, there are a lot of things that you can now do with deployment stacks.
They are visible in the subscription resource level, the deployment stack?
Yes. Because what do you know? CUF demo. Deployment stacks. Here they are. So we're running out of time, and I do want to give Johnny enough time to set up as well, because I know I appreciate it when I have to present. there's just two things that I want to say. You didn't ask about support for Enter ID. If you start looking at that, know that you shouldn't look for something like Microsoft.enterID/groups or /applications, but you should look for Microsoft.graph, because what they're actually building is a resource provider for Microsoft Graph, which allows us to hope that a lot of resources that we can access using Graph eventually will also become available using Bicep. The biggest showstopper there is idempotency on the underlying Graph APIs. And the other thing that I want to point out is if you want to see that larger example or have other questions, feel free to find me. I'll be here all day, but tomorrow I have to leave pretty early to catch my flight. So find me if you have any questions. Thank you for your attention.
Thank you, Henry. We will continue with the next presentation in roughly 7 minutes, so be back then. All right, welcome to the next presentation about quantum computing. I'm at least excited. Go ahead, Johnny.
Thank you. I'm excited too, if that's a good thing. So yeah, today I wanted to talk to you about creating a quantum algorithm. I decided, instead of just talking quantum theory, I also wanted to show you what quantum programming actually looks like, and that's why I'm going to do a live demo. So I'm very happy that at least some of you decided to show up and to do some different kind of session. So my name is Johnny. I am from Belgium. From Belgium all the way here to Finland. I'm not going to talk about myself a lot. The only thing that I'm going to tell you is that if you see this QR code, if you follow the link, and you follow the links in the bottom of each slide, it already takes you to a GitHub repository that contains everything that I will show you today. So all the code examples are there, even code examples that I did not show you, and the whole slide deck is actually already there. So you could basically just walk out right now and just look at it online. But if you decide to stay, I can tell the story with it, of course. All right? So first, I'm going to do a little introduction, like a 15, 20-minute introduction on what quantum computing is, and then I will spend the rest of my session doing live coding and hopefully make you understand what a quantum algorithm can actually look like. So before I talk about quantum computing, I want to take you back to my childhood. Why? Because when I was a teenager and I was attending school, a teacher actually knew that I was playing around with writing little computer programs. My mom had a very old MS-DOS computer, and I wanted to learn some programming because I was basically creative as a child, but very lazy. So creative as a lazy person is writing code. So the teacher came up to me and he told me, yeah, I have a little challenge for you. So you know a chessboard has 64 squares, you have different kinds of chess pieces, and one of the chess pieces is represented by a horse, that's the knight. And a horse or a knight can do very specific jumps. It can jump, for example, on the left-hand side from that specific position to 8 different positions on the board from that origin. The teacher told me, could you write an application that actually tries to find a unique path that visits all of these squares just once? And on the right-hand side, with my beautiful paint skills, I actually did one of the possible outcomes. And back in those days, when I was, I don't know, 14 years old or something, I said, okay, this is actually very simple to solve, because you basically just brute force, you just try, walk around, and when you're stuck, when you can't jump anymore because you visited all the squares, you just take a step back and try a different route. Now, when I was 14 years old, I never heard of recursion. So I basically put 64 for loops nested within each other to make that work, or at least I thought that would work. I pressed start on this old MS-DOS computer and nothing happened, no output. So it was processing. It took a while. I waited for minutes, I waited for hours, I even waited overnight, and still I didn't get any output. And this was the first time in my life that I got acquainted with something that is called an exponentially large problem. It can actually be that you take the wrong route every time and you spend ages trying to find the correct route, because there's so many permutations, there's so many possible routes that will fail, and there's only some of them that will actually succeed. So for this old classical computer, it was not possible to solve this problem in a matter of minutes. So this was the first time. Of course, today in computing, we have the same problem. We have problems today that we cannot solve with classical computers, so we are looking to different kinds of computers to hopefully solve these kinds of problems. Quantum computers are hopefully computers that can help us with that. And what is a quantum computer? Well, a quantum computer is a computer based on the quantum principles, or the principles from the quantum mechanics space. Two principles that we are actually going to leverage within quantum computing is called superposition and entanglement. You probably heard about those. Superposition basically means that on a very small scale, so on a quantum scale, so very tiny particles, they can have a property, for example, the spin of an electron in the left-hand side image. The spin of an electron is kind of a binary property. It can be up or it can be down. So for us, it's very easy to understand. It's binary. Up can be, for example, 0, down can be 1. Now, superposition means that in practice, the property can also be both at the same time. That's not really true. It's not both at the same time. It's just basically not existing yet. So it's kind of a probability thing. So it can be up or it can be down, but let's say the universe hasn't made that decision yet. It's only when we make an observation that it will actually flip to either up or down. And this is what we call superposition. It only works on a very tiny scale. So it only works for electrons, atoms, stuff like that. They have these properties. Some of these properties can have binary states, and they can also be in a state of superposition. On our macroscopical level, this does not work. So we never see this happen because it just doesn't happen at our scale. The only thing that I sometimes have is like when you have like this old school USB-A connector, you try to put it in the USB slot, it never fits. You can turn it around multiple times. It's only when you observe the slot that it basically collapses to its correct orientation, and then it will fit. That's the same thing. But this really happens on a very tiny scale. On the right-hand side, there's an image that represents entanglement. Entanglement, it's even more weird. When you have two microscopical objects or quantum objects that have a quantum superposition, they can be in a form of entanglement, which means that they influence each other. If you observe one of the two, it will collapse its superposition, and it will be either one of those binary values. And the other item will immediately collapse to the opposite position. And we don't know how that works. There's no scientist that actually can prove how that works. It even works on large distances. So when you have entangled quantum objects and they are very far apart, if you observe one, the other one will collapse to the opposite state immediately. There's no delay, so there's no communication. We have no idea how that works. But it does work, and we can leverage these things to actually build computers that can do very, very weird things. By the way, these are my drawing skills. This is not what it looks like in real life. This is just a representation that I did to better explain what superposition and entanglement is. Welcome to the new people. So yeah, why are we building quantum computers? I already told you, because we have very hard problems that we still cannot solve today. Problems that can actually, when we can solve them, can actually help us to save the polar bears. Because climate is really a thing. We really need to look out for our planet. We need to spend less resources on the things that we do. So if we want to solve a very big problem, we are basically throwing millions of classical computing instances towards that problem, and hopefully we can solve a part of it. But of course, that takes energy. The same with AI and machine learning. We spend a lot of energy today just to generate stupid pictures like this. I'm sorry, polar bears. But there's all kinds of things, like drug development, for example. When we create medicine, when we design medicine today, we have kind of an idea how the human body works, but not in detail. We don't know every detail. So we basically try something, we build some kind of medication, and we test that medication on animals. If the animal dies, we go back and try again. It's the same as we developers. We run our application, it fails, we try again. But of course, with medicine, we can't try on people, because when a person dies, that's horrible. But for some reason, animals dying is not horrible. Again, with quantum computers, we hope to have that exponential, we hope we can solve those exponentially large problems or solve them better, so we can basically create some kind of a simulation of a human body. And when we have that simulation, we can run that simulation a couple of times and test our medicine that way. And it's the same with AI and machine learning. I already told you that we spend a lot of energy on AI and machine learning today to make these models that are almost perfect, but actually it's a statistical thing. In order to make a perfect model, you basically need to train it for an indefinite amount of time, which we don't have. If we have faster and stronger computers, we can make those models better. So again, quantum computers, when they are better at exponentially large problems, they can actually solve this problem for us. I'm not going to talk about the other things because I don't have time. I want to show you other cool stuff. But let's go back to basics. We all know classical computers because we are IT people, right? We know that in a classical computer we have things called bits. They can have two distinct states, 0 and 1. And we can combine those zeros and ones and represent all kinds of data. We just throw them together, we decide on a protocol, or we decide on a format, a data format, and we know what the data represents. Now, in the quantum space, we're going to do the exact same thing. I told you we're going to leverage quantum objects that can be in superposition, but when they are not in superposition, they also have binary properties, like the spin up and spin down from an electron. And this can be represented by 0 and 1. So it's the same. We will think in the same way. The only difference is there's a kind of a different notation. If you see something like this, you know it's a quantum 0 state and a quantum 1 state. This is called the Dirac notation, which is basically a vector notation from linear algebra. So now you know it's a quantum vector that represents the state 0 and the state 1. We can also combine in the quantum world, so we can combine states for qubits or quantum bits to represent data. Again, the same thing. So we don't need to learn new things here. Everything from the classical world also works in the quantum world. But things become interesting when we involve superposition. So when we involve superposition, we basically create a probability expression that will express how much probability there is to collapse to 0 and how much probability there is to collapse to 1. And these are the alpha and beta values. And now it gets a little bit mathematical. When we do classical computing, it's basically also mathematics. It's logic, it's pure logic. When you have zeros and ones, you can do operations on them. You can do AND and NOT and exclusive OR and other kinds of operations. And those operations are quite easy to do from the back of your head or from the top of your head. You don't need a piece of paper for that. But in the quantum world, when you were working with superposition, things get complicated, and we need some additional mathematics, linear algebra, to actually calculate what the result for a specific operation is going to be, and that's why I'm showing you a little bit of this math. Now, this expression always ends up being 1. 1 meaning 100% chance. It's 100% chance of either being 0 or 1, and it's just divided between those two, alpha and beta. If you look at this expression, it means that your alpha value, the absolute value of your alpha value needs to be squared, and you need to add the absolute value of beta, and that needs to be squared, and the result needs to equal 1. Now you're looking at me, why are you taking the absolute value when you're doing a square operation? Because mathematicians are assholes. Alpha and beta are complex numbers. So we are working in three-dimensional space. When we look at the superposition state vector, alpha and beta combined, two complex numbers, 3 dimensions. You probably know, again, mathematicians, I hope there's no mathematicians in the room, but when they can't solve a problem, they invent new dimensions, and then they can solve their problems. So the state, the superposition state, is actually a state that can be represented in 3-dimensional space. And if you look at the perfect 50-50 superposition, that's going to be something like this. 1 over square root of 2 is half, and 1 over square root of 2 is half. Why? Because you need to square it. So 1 over square root of 2 squared is half. Half times 0, half times 1 is 50-50% superposition. And this is what happens in a quantum computer. If you put your qubit in superposition, it can be this value. And then you can actually very carefully change the superposition state to some different vector that has different probabilities. It can be 75-25, as long as the total is always 100%. Now, because math is hard, we humans like visual representations of that. It's actually nothing more than, as I said, a vector in 3-dimensional space. So we have a sphere. This is our vector space that we define specifically for the state of a quantum bit. So if you remember your linear algebra, which I actually failed in university, because now I know what it's useful for, not back then. So this is our vector space. It has 3 axes, x, y, z, so 3-dimensional sphere. The length or the radius is actually 1, that's our 100%. And we can put a vector that originates from the central point, and it can actually point wherever on the surface of the sphere. On the right-hand side, you will see that vector psi or phi or whatever, pointing somewhere up. Now, if you look at the distinct 0 and 1 states, those live on the z-axis. So the 0 state is pointing way up. So that's 0. And when the vector points down, this is 1. Everything in between, which is an indefinite amount of possibilities, is some kind of superposition. Now, if you have a perfect 50-50 superposition, your vector will live somewhere on this plane, combining the x and the y axis. Why? Because this plane, when the vector points right, for example, is exactly in between 0 and 1. So the distance it needs to travel is the same. Now, if you look at the right-hand side image, so that vector points somewhere upwards. Doesn't really matter where it points exactly. What are the chances it collapsing to 0 or 1? Anyone knows? Are the probabilities higher of it collapsing to 0 or higher of it collapsing to 1? Higher to 0. Why? Because it's closer to 0. So this is why I like to show you that graphical representation, because now you can see indeed that the chances are higher. And we already talked about linear algebra. You can also use some trigonometry to actually calculate the percentage, because you know your sines and cosines. Basically, when you do a little dotted line here and a little dotted line here, you know the angle of your vector. You can actually calculate what the percentage of chance is to collapsing to 0 and what the percentage is collapsing to 1. So this is just basic trigonometry. And if you dumb it down a little bit to 2 dimensions, that's exactly what we're doing. If the vector is exactly in between, which is, as I told you, 1 over square root of 2 plus 1 over square root of 2, the angle is pi over 2. You can actually use the sine and the cosine, and the result you will get is actually half-half. If you do it on the right-hand side, where your angle is 2 pi over 3 radians, and you do your sine and your cosine, you will get 1 over 2 and square root of 3 over 2, which is actually 1/4 and 3/4, which is 75%. So this is what you need to know about calculating your probabilities when a quantum bit is in superposition. So it's a little bit more mathematical because, of course, you can't do it from the top of your head. All right, now that we know this, why is a quantum computer more powerful than a classical computer? Well, if we start combining these superpositioned qubits, we actually go exponentially. So if you have a 2-qubit system, you have 4 probable values or 4 probable outcomes. You have 0, 0, 0, 1, 1, 0, 1, 1. Now, if you add a single qubit, it always doubles. So now you have 8 probabilities. For a 4-qubit system, you have 16 probabilities. And depending on the algorithm that you're writing, if you put all of your qubits in superposition, they basically represent all of your different outcomes at the same time. Now, if you really go very quickly and you think about it, if you look at a classical CPU, in order to double the power of your classical CPU, you need to double the amount of transistors that can represent bits. So that's quite hard to do. But for a quantum computer, if you want to double the power of your quantum computer, you only need to add 1 single qubit, which is quite powerful. Now, I don't work for the media. When I say in a quantum computer, when you add 1 single qubit, it doubles the power of the quantum computer. What the media does not tell you is that when you add 1 qubit to a quantum computer, you exponentially make it more difficult and more unstable to actually work with. So this is why quantum computers are not really a thing today. They exist, we can use them, but they're quite small. Not physically small, I mean they don't have a lot of qubits. Because when we add qubits to that system, it becomes exponentially more unstable because it's very hard to keep all of those qubits in superposition when we need to. So yeah, we're still working on that to actually make those stable by trying to find the correct quantum objects to put in superposition and all of those things. Now, if we look at creating an algorithm, we're actually in the level of circuits. You probably also know that when you're using classical computers, basically there's a bunch of circuits within your CPU. You can have specific functions that you can call on your CPU, and there will be a circuit connected to that, and that circuit will actually work with those binary numbers. In a quantum computing space, it's the same thing. We have lines horizontally representing the time and one of the qubits, and then we have different gates where we put those qubits through. Exactly the same as in the classical space. In the classical space, you have bits, you put them through gates, stuff happens at the other side, at the other end of the circuit, and in quantum, it's the same thing. This is actually the quantum teleportation circuit, because in the quantum space, you cannot copy values. You cannot copy the state from one qubit to another qubit. That just doesn't work in quantum. So if you have a very specific superposition state, you can never copy that to another item. You always need to perform the same steps in order to get to the same state. Except for this little circuit. This little circuit will actually teleport this specific state, which can be whatever, to this specific qubit. Very weird. Teleportation means that the original one will be destroyed. So you don't take a copy, you teleport it to another qubit, and the original qubit is destroyed. Or at least the state is destroyed, not the qubit. That would be a very expensive quantum computer. Now, how this works, this is a little story about Alice and Bob. We know those people. Alice and Bob want to share some data. Alice actually has hold of the message, but Bob does not. So Alice wants to give the message to Bob. So the first thing that Alice and Bob will do, they come together. They will make sure that they have 2 qubits, and they will entangle those qubits. So this is qubit for Alice, this is the qubit for Bob. They basically, Alice puts her qubit in superposition. The H or Hadamard gate puts a qubit into superposition. And then they will do a C0 operation to actually entangle those 2 qubits together. And now they are entangled. A C0 gate is a very easy gate. It basically means when this qubit is 1, this one is flipped around the x-axis, which is just a not operation. Because the x-axis, if you remember from the sphere, if your vector points straight up the z-axis, it's 0. When you flip around the x-axis 180 degrees, your state becomes 1, and vice versa. So it's a not operation. But it only works when this one is 1. When this one is 0, nothing happens. but this one is not 1, it's not 0, it's in superposition, which now makes these 2 qubits entangled. Now, they started out as the 0 state, now they are entangled, and in superposition, of course, and the message qubit is some arbitrary superposition state, we don't know. Now we entangle the message qubit with Alice's qubit, and this is where things become interesting. Now Alice and Bob, they can go far away from each other. Bob can take the airplane to Australia if he wants, Alice can stay here, and the following thing needs to happen. Alice measures her qubit, and when she measures or observes the state, she collapses the qubit into either 1 or 0, the 2 base states. Now, when the result is 1, she will call to Bob, or she will send an email or a WhatsApp to Bob telling him, I got 1, which means you need to put your qubit through the X gate. Again, the X gate, 180 degrees around the X-axis. Then she does the same thing with the message qubit. She measures it, destroying the original state, so the original message is destroyed. If she has 1 as a result, she again calls to Bob, and she tells Bob to flip his qubit vector around the Z-axis, 180 degrees. And for some magical reason, the exact same message state is now teleported to Bob's state. And this is a circuit you can actually run. You can run that on Azure Quantum, on a real physical quantum computer if you have time, because there's a long queue, because everyone is trying all of these things. It works. It will actually work, which is quite spectacular. Now, very quickly, Azure Quantum is one of the resources that Microsoft has in Azure, and Microsoft is working on building their own quantum computer. But they're not finished yet. They are working on a very hard way of doing a quantum computer because they think that is the best way of building stable quantum computers. So they are working on a topological, on a quantum computer that is using topological qubits. I tried to read the paper for that, but I have no idea what it's about. I'm not an engineer, I'm not a physicist, so I just don't understand what they are doing. I hope they understand what they are doing, because they're not ready yet. There's other vendors, other hardware vendors that do similar things, but they use different kinds of quantum objects. For example, you have IonQ and Quantinuum. Those are 2 companies that are building physical quantum computers using ion traps. So ion traps are basically ions that they use to represent a qubit, and they use lasers to actually change the superposition very carefully. So by using lasers, they can actually change that vector in that sphere to have a different kind of superposition state. Then there's QCI and Rigetti, and by the way, also IBM. But IBM is not available through Azure Quantum. They are using superconducting qubits, which are electrons, and they can change the superposition state by using microwaves. So each company is basically trying to build their own quantum computer in their very specific way because they think that is the best way to do it. And then this is a new one, Pascal, using the neutral atom. I haven't looked into that, so I have no idea how that works. Now, Azure Quantum is basically a workspace where you get access to one of these quantum computers. The one from Microsoft you can already target, but they will basically do a simulation, and they will tell you how many resources you will need when they eventually have the quantum computer finished. These ones have simulators available, but they also have the physical quantum computers available. But if you want to run your algorithm on one of these, there's a long waiting line, so you need to wait for hours before your stuff actually gets run. And how it works is pretty much the same way as .NET works. It works by first taking Q#, which is the language from Microsoft for writing quantum algorithms. They will compile that down into an intermediate language, just like .NET. And .NET and C#, they go to intermediate language. In the quantum world, we go to quantum intermediate representation. And then the quantum intermediate representation is then compiled down to machine code by the very specific hardware vendor. So each hardware vendor basically creates a driver for their hardware. They will compile QIR down to machine code for their specific machines. Now, Q# is a language that we can use today to learn about quantum. Maybe you're super smart and you have the new quantum algorithm already available. But I'm going to show you a very simple quantum algorithm because we have 25 minutes remaining. So let's see where we can get with this. So I've created a game. I did not create this. This is actually a game that's been invented multiple decades ago to prove a very specific aspect of quantum computing. And I'm going to use this just as an example, because this will take me around 20 minutes to explain to you, and hopefully you will understand, and you will understand what the power of quantum can be, and also how you need to think out of the box to actually do something useful with a quantum computer. It's not easy, so please try to stay awake and try to follow what I'm going to talk about now. So the game is called the CHSH game. Those are just the initials of the people who invented this specific algorithm. And it's a game of luck. It's a game of luck. So we have two people, or animals in this case, playing this game. We have Jaakarhu and we have Pingviini. This is my best Finnish accent. And they're going to play the game. And why is it those two animals? Because they can't speak to each other. So the Jaakarhu is living on the North Pole, and the Pingviini is living on the South Pole. So they can't talk to each other. And both of them will get a random number, 0 or 1, as input. Now, when both received their random bits x and y, they need to output random bits a and b. Now, when they do this, the expression in the bottom needs to be true in order to win the game. So when the input x and y multiply together equals the exclusive OR for a and b, then they win the game. But they can't speak to each other, so they can't influence their decision, and they don't know what the input x and y for each other is. Very weird game, right? Now, if you think about this, and if you put this in truth tables, you know when x is 0, 0, 1, 1, and y is 0, 1, 0, 1, you know the result of the left-hand side of the expression, 0, 0, 0, and 1. And for the right-hand side of the expression, you can do the same thing. If you have a and b in all of their different values, and you do the exclusive OR for a and b, you get those values. So look at this. How can they win this game? Well, basically, when they cheat a little bit, and maybe they're together in a zoo somewhere. They're together in a zoo, and they know that they're going to need to play this game in the future. They can basically tell each other, you know, when we ever need to play this CHSH game, we're just going to output 0. Is that okay? Okay, so we're just going to output 0. Then the zoo sets them free. One goes to the North Pole, one goes to the South Pole. For some reason, they now get a telephone. They need to play this game. Okay, remember, we needed to output 0. So if they both output 0, you look at the right-hand side, the only thing that happens now is the top line, so 0, 0 becomes 0. So the output of the right-hand side of the expression is 0. Now, in how many cases is the left-hand side of the expression 0? In 75% of the cases, 3 out of 4. So basically, when they talk to each other beforehand, like I told you, and they decide to always output 0, they have a 75% chance of winning this game. If you do this at a casino, that's a very nice winning percentage. So in the classical world, they can win this game in 75% of the cases when they always output 0. I'm going to show you that in the quantum world, they can increase their chances. But let's start with the classical one. So we go to something that is called Q#, which is the language to write quantum algorithms. And we're going to implement this classical version of the game. Then I'm going to implement the quantum version, and we're going to compare. So we're playing this game. All right, let's create a variable called number of games equals 10,000, because it's a statistical thing. We need to run it multiple times in order to know what our win percentage is. And we need to keep a mutable variable with our classical wins, and they're going to be 0 to start with. We're going to have our quantum wins, and they're going to be 0 to start with. And now we're going to run the game 10,000 times. Yeah, GitHub Copilot, I don't need you now. So for I in 1 to number of games. Now it doesn't look like I'm smart. Now I'm just typing what it's proposing. Whatever. So okay, we play the game. The first thing is we need to get those random input values, x and y. Those are random, so we need to generate them randomly. So let a tuple of x and y equals calling a function generate random bits. So in Q#, you also have the concept of running a function, an operation. So I can create a new operation, generate random bits. It takes no parameters, and it returns a tuple of two booleans, true or false. I told you, we need to work on this classical version first, but I'm going to use a little bit quantum in this classical version. Because if we can never make quantum computers stable, the only thing that they can already do today really good is generating real random numbers. Like a classical computer only does pseudo-random numbers. Like when you have a quantum computer that only has one qubit, put it in superposition, measure it, true randomness, nature random. Very cool. So I can actually use the use function to create a tuple of two qubits, Q1 and Q2. And I'm going to use the qubit factory function to not generate a qubit, but to allocate a qubit to that specific variable. So because qubits are very expensive, you know this from C#, for example. In C# it's called using. In Q# it's called use. You basically use something that is very expensive, and when you're done with it, you deallocate it automatically when it goes out of scope, and then the system has the quantum bit available again for the next purpose. Now we put those two qubits in superposition by putting them through the to the H gates. So now they're both in superposition. And now I can return a tuple where we do a measurement for the first qubit, and we do a measurement for the second qubit. Now this looks a little bit weird. What I'm basically doing, because Q# is a little bit like C#, it's a very type-safe language. So the result of a measurement is always 1 or 0. And 1 or 0 are of type result and not of type Boolean. So I need to compare this measurement result to 1. And if they're the same, it's true. So that's how I convert 1 to true. mResetZ is actually a helper function that does a measurement. That's what the M stands for. And reset stands for the fact that after I've measured my qubit, I'm resetting it back to its original 0 state before I return it to the system. This is something specifically to Q#. When you have a qubit that is in the state 1 or is still in superposition and you return it, it goes out of scope, you get a runtime exception because you always need to put your qubits back into their original 0 state. The Z stands for measuring on the Z-axis. I told you the Z-axis, 0 in the top, 1 in the bottom, that's measuring on that specific axis. So now I have my two random numbers in a quantum way. Now I'm going to generate my A and B by playing my classical game. And of course I need to provide my X and Y values. So this is playing the game in a classical way, and I told you they just need to return 0, 0 in order to have a 75% win chance. So operation play classical. I'm going to input two booleans, and I'm going to output a tuple of two booleans. And as I told you, we're just going to ignore the input, and we're going to return false and false, or 0 and 0. That's it. The only thing I need to do now is compare the two sides of the expression. So I'm going to create a variable left-hand side of the expression. And the left-hand side was just a multiplication of two booleans. I can't multiply booleans together, so I need to convert them to integers. So I have a helper function that I can use, bool array, not bool, bool array to int. And I'm going to create an array containing only one bit x, and I'm going to multiply it with y. So basically, when you have a couple of bits, you can convert them to an integer. But we only have one bit, so 0 becomes 0, 1 becomes 1. Very easy. Again, it's a type-safe language, so you need these kinds of things. And it looks like C# because we need an extra namespace for this. We need to open or import the convert namespace to be able to convert from one type to the other. And now these functions should be available to me. Why are you not available? Bool array, okay, as int. Yeah, you need to know your base class libraries. Now we're going to do the same for the right-hand side of the expression. So let right-hand side be the exclusive OR. There is no such thing in Q# as doing an exclusive OR, unfortunately, so I need to do it a different way. So I can do the modulus I, or modulo, I actually don't know, for the bool array as int for A, plus the bool array as int for B, and divide them by 2, and the remainder after division will actually be your exclusive OR. That's the same thing. Again, in order to use the modulus I function, you need to include the math namespace. Modulus I seems to be correct. Now I need to compare the left-hand side and the right-hand side of the expression, and if they're equal, we know we won the game. If they're not equal, we lost the game. So I can do set in order to change the variable called classical wins. And I'm going to increase it if the left-hand side of the expression is equal to the right-hand side of the expression. And if that's the case, I'm going to add 1. Otherwise, I'm going to add 0. So this is not the most performant way of doing this, but now this is an if in just one line of code, which I like. So I'm adding 1 if it's equal, or I'm adding 0, nothing, if it's not equal. And that's it. Doing this 10,000 times, I can show the result in a message. A message is a console write line, basically. If you run this on a physical quantum computer, you get the result back in a JSON file. And that's your output, basically. It doesn't output on the physical quantum computer. It outputs in the result that you get back. So the classical wins is, I'm not going to do it this way. It's the classical wins divided by the number of games times 100. Jesus, 100%. So number of games is actually, it's an integer. Classical wins is a double, so I need to do int as double. This is very annoying. And then I'm going to round it to whole numbers so that it looks nice like that. So this is the classical way of running this algorithm. So run, and the result in the bottom is now 75%. So it's correct, because we just saw 3 out of 4 times the result is going to be 0. So 75% is actually our win chance. Now let's make things a little bit more interesting. Those 2 characters or animals, they can actually use or leverage quantum effects to increase their win chance. So we're going to provide them with an entangled qubit pair. So we have 2 qubits. Those are going to be entangled, and we will provide one to Jakarhu and one to Pingvini. Now, they can go to their North Pole and South Pole. They can keep their entangled qubit, and they can now do very interesting things because they can influence each other. They still are not able to communicate to each other, but they can influence each other. And this is basically where quantum computing becomes very interesting. You really need to think out of the box in order to make something like this happen. And I told you, this is the 2-dimensional version of all of the different states that we can have. There's basically different ways of measuring a qubit. When you measure a qubit, it collapses to a very specific state, 0 or 1. But you can actually influence that, and you can measure in different, what they call bases. So we have something called computational base, where the result is going to be 1 and 0. But we also have something that is called a sign base, where the result can be plus or minus. And this is actually positive superposition and negative superposition. I told you, you can measure on whatever base you want. So if you look at the block sphere, this one, you can actually influence where the vector collapses to. By default, it's the computational basis like this. But you can do the sign basis, then it will collapse to either here, or you can choose whatever base you want for your vector to collapse to. And this is what we are going to leverage for this specific game. So on the left-hand side, Jakarhu is going to measure in the computational or the sign basis. And Pingvini is going to measure in the negative pi over 8 basis or positive pi over 8 basis. And when they do this, you have basically 4 different outcomes. When the input values are 0 and 0, when the input values are 0 and 1, when the input values are 1 and 0, and when the input values are 1 and 1. So 4 different scenarios. So let's already put that into code. So I'm going to copy playing the games 10,000 times. I'm going to play not the classical version, but the quantum version. There's going to be here a number of quantum wins. Quantum wins. This is quantum wins. When you copy paste things, you're going to mess up somewhere. So we'll see what happens. That's it. And I'm going to copy this function, play classical, into play quantum. Now, I can already prepare this a little bit. I told you we basically need to have 2 qubits entangled. So let's do that. So first, we have a mutable tuple with the A and B output values. We'll assign false and false to them, and we will return them at the end of this operation. And now we're going to define the 2 qubits. So use tuple qubit Q for the first one and the second one. So those are the 2 animals, J and P. We have 2 qubits. We put the first one in superposition, and we use the C0 operation to entangle them. There we go. And then I told you, you basically have 4 different possibilities for your input values. So if x equals 1, you need to do something else.
Did you need to put the other qubit in the superposition as well?
No. So when you're so the question was, do you also need to put the other qubit in superposition in order to reach entanglement? No. You just put one of them in superposition, and then you use the C0 operation on the other one. So you use the superposition one as the control parameter, and you use the target one is the one that is not in superposition. And that is your entanglement. So if x is 1 or x is 0, and then if y is 1, else, whoops, there we go. So these are our 4 different options. So let's look at those options. 6 minutes remaining. There's going to be a lot of headaches, unfortunately. Sorry. So let's look at the first specific one, when both are 0. So what's going to happen? Karhu is going to basically decide when x equals 0, it's going to measure in the computational basis, and we have 2 possible outcomes. The outcome can be 0 or it can be 1, because now we collapsed the superposition of the left-hand qubit. Now, we can write that down. She outputs 0 or 1. And we also know that when this actually collapses to 0 and this collapses to 1, it influences the one for Pingvini. And you can see in red where I actually put the vector. So pointing to the right, the same as on the left. Pointing to the top, the same as on the left. But Pingvini is going to measure on the -π/8 basis. And now you can see that in order for this vector that already collapsed there, so it influenced this one, which also collapsed to the same position. By the way, I told you in quantum physics it collapses to the opposite state. In quantum computing it collapses to the same state. You can do a different kind of entanglement where it also collapses to the opposite state, but by default it's the same state. And now you can see that if we measure on this basis, that this vector will probably collapse to this state because this one is closer. It needs just to collapse here instead of collapsing all the way over there. So when this is 0, Pingvini will also be 0. And when this is 1, Pingvini will also be 1 because they are closest together. And if you look at this in the 4 different versions, you will see that we can create an advantage. So let's look at the second one. It's the same thing. X is still 0. So we still measure in the computational basis, but now y is 1, and we're going to measure in positive π/8. And you see the same thing. If red is 0, blue is also 0. If red is 1, blue is also 1. And if we look at the final one, so we're going to skip the third one because it's the same story. But if we look at the final one, Now, because x is 1, we don't measure in the computational basis, we measure in the sign basis. It can be positive superposition or negative superposition. And if y equals 1, we measure in the positive pi over 8 radians. Now it's different, because when it's plus or 0, it's going to collapse to 1 here. And when it's minus or 1, it's going to collapse to 0. And if I put this in code, 3 minutes remaining. So let's think about this. So x was computational or sign basis. So that's easy. So I can do set a. So a is the output for the polar bear, equals m reset z for its qubit. And it's going to be the same. Now, I can't remember this by heart, so I always need to check. So one is going to be in the computational basis, one is going to be in the sign basis. So if I remember correctly, the computational basis where x equals 0. Yes, so this is the computational basis for x equals 0. So that's an m reset z. So when x is 0, that's measuring on the z-axis. When x equals 1, we need the sign basis. That's going to be the x-axis. All right, so these are those measurements. In Q#, unfortunately, you cannot measure on whatever basis. You can only measure on the x, y, and z basis. But in Q#, you can rotate your vector in every direction you want. So I can first do that. So I can actually do ry, which is a rotation around the y-axis with pi over 4. I told you it's pi over 8, but it pisses me off a little bit, but it's a nice story because, dear developers, read your documentation. If you look at the documentation for the ry operation, you will see that they will divide your angle by 2. So if you do pi over 4, they divide it by 2, it's going to be pi over 8. So if you need pi over 8, you need to type pi over 4. Crazy. QP, so we rotate pi over 4, and again, I need to check, I need to verify which one is minus and which one is, I think the 0 one is minus. When y is 0, it's minus pi. When y is positive, it's positive. And then after this, I can actually do the same thing. I can also measure in the z basis because we already did the rotation. So set b equals qp, and it's the same for the other one. Whoops. I can also put that behind the if statement, but whatever. That's it. Those are the 4 different options. Is anyone super smart, or did anyone look at the slides? What is the percentage of win? 85. It should be 85. So it's more, and it should be 85. So let's run. It's 86. It's even better. So classical wins 75%. Quantum wins. Now we win in 86% of the time. And again, this is pure mathematics. So if you, again, look at the mathematics in the bottom, you just know what your angle is. Your angle is pi over 8, depending on how it's oriented. It can also be 5 pi over 8, because minus pi over 8 is the same as 5 pi over 8. And if you do your cosine and your sine, you get your probabilities. You square those values, and now you know that it's 85% chance and 15% chance for those 2 specific values. Now, this is a useless thing that I just showed you. This algorithm does not make sense. I mean, you can't use this in your day job. I can't use this in my day job. I just wanted to show you how you need to basically think out of the box in a different way to make a quantum computer more powerful. Is this more powerful? Yes, because we have 85% chance of winning this game instead of 75. So it's a very small example of how a quantum computer can be more powerful. Again, this is useless, but it gives you an idea. If I want to show you a real quantum algorithm, I need days in order to explain something like that, because they are so complex. But the idea is the same in classical computing. We are not creating circuits for classical computers. When we create algorithms, we use libraries, we use frameworks to do all of those hard things for us. And it's the same in the quantum world. So in the quantum world, if I go back to my slides, here, we are going to open namespaces that have packages for very specific use cases. Q# and the base class library for Q# has packages for chemistry, has packages for physics that we can reuse to actually write programs. So we don't need to do this basic circuitry stuff. No, we just call functions, we call operations, and we use functionality that already exists. So that's the idea. We're going to create higher levels on top of this circuitry to actually make things work. Very cool. So that's basically it. Let's go to the end. One thing that I wanted to show you is when COVID hit, I got a question, do you want to write a book? Normally I would say no, but it was COVID. I had nothing else to do. So I said yes. And the thing that I showed you and all the explanation is basically in the book, but more extensive. So I'm basically trying to explain for a software developer, because by the way, I didn't tell you, I'm not into quantum computers. I don't have a quantum computer at home. I don't work with quantum computers. This is a hobby that got out of hand. So I'm just very interested in the topic. So I basically wrote all of my ideas on the level of a developer and not on the level of a mathematician or a physicist. So this is what's inside of the book. And by the way, it's approved by Polar Bear, so I guess it's fine. I also have one copy with me, if you want to have a look. I will put it here in front of me. And if you come to the Azure party, after party tonight, I will take this book with me. And the first one that comes up and talks to me, so I can take a picture and tell my mom I have friends, and tell me a cool thing about a polar bear that I don't know, you will get the book for free. And with that, that's the end of my presentation. Thank you. If there's questions, I'm here, and have a nice continuation of your conference.
Thank you. Next, we have the coffee and break behind this wall. So go get some of that, and we will continue at 2:30.
Maybe I can find an answer. Feelings growing inside to leave my holding anchor. Maybe I can find an answer. Feelings growing inside to leave my holding anchor.
Yep.
All right. Welcome to the last session of the day. We do have the panel and the after party, so it's not all over after this either. But I've heard that now we have the best testing session of the conference coming up. So let's give a big hand to Sam.
Thank you, and thank you for stealing my opening line, where I was going to say, welcome to statistically the best session of Igloo conference on testing. Anyway, I'm Sam. I flew in from Belgium, happily, of course. I think this is my third Iglooconf, maybe my fourth. And I'm also Microsoft Azure MVP. I've been actually building my career in a company called Codit, where I was CTO and co-founder. So there I learned all the things with backend and integration and so on. But then we got acquired by a company in Belgium, and after that, let's say 3 years later, I left the company because I wanted to do, instead of working for a large enterprise company, I wanted to do things, getting my hands dirty, going back to building stuff, and that's where I said, okay, I want to work with startups. So I have my own startup, which is called Sphinx. We do physical access management, so opening smart locks of all different kinds in a way that, you can control who is entering your house and when. And next to that, I also have a passion for cycling and traveling. Now, that last passion, maybe the last but one, but the cycling is the thing that I will use, to explain the testing approaches that I do. Because next to my job, what I've been doing in the past 5 years, I think, is also building an application that is called Kotacol. It's quite Belgian. Because it's actually based on a historical encyclopedia that was built in the 80s by people making a list of 1,000 different hills that you could ride with a bike. With their profiles, they give it a score and things like that. So it's quite impressive, especially because I don't think there was Excel back in those days. So they were really mathematicians and people riding bikes. So they were doing all these things by hand, making those drawings. What we did with 3 people was making sure, okay, let's make a digital version of that. So there's an app, there's a website, and there's integration. So what we say is that if people go cycling and they register on our platform, if they use Strava, who knows Strava? Okay, most people, so it's a sports platform. So if you use that, you actually give us permissions to read your activities, and we will detect if you have conquered one of these 1,000 different hills in Belgium. That's what we do. There's a score, like how much calls did you cover and things like that. So we have an app. That's the thing that I have not built. But the things on the right I did. So everything with integration with Strava, and that's really backend oriented, I did. And I also built a website. As I said, my background really is in backend and integration. So probably my code is looking better than the website, but still I tried to broaden things up. And actually, Blazor has been quite helpful for me because I don't know anything about JavaScript, but still I was able to build some kind of website that I still like. For this, I have been doing setting up tests. And why do we test, of course? Yeah, because we love it? Probably not. Because we always get enough budget and time for it? No, I don't think anyone said that. But at the same time, I think we all realize that we get benefits and advantages from doing that. Of course, bug detection, having consistency and reliability, and a peace of mind. If you can say, I released this new feature, and you have an automated way of doing the stuff that you always hate and that you always want to skip, the manual testing, you have much better confidence in deploying stuff. So I think it's quite key. And it also helps sometimes in documentation, in my opinion. So I have been applying a lot of different things in practice for that startup, but I will use the community platform, so the Kotacol, in most of the demos. The session today is totally not about theoretical things. If you're a real, pure test theoretical person, you will know much more things than I do. The thing I want to share is how I now, I'm now a person responsible for virtually anything that is on the technical side, because the startup has 2 people. One is doing more sales, commercial things and investment, and I'm doing the development, the testing, the DevOps, whatever you have, so getting the hands dirty. So it's a very pragmatic approach. This is not the one size that fits all, but I will focus on the 4 different things here. So unit tests, we will talk about integration tests, which in my opinion in platforms like this are the most important. I'll show you how you can do load tests with Microsoft Azure, and of course some UI tests, because even though my UI is not looking sexy, it should still work, and that's the whole intention. Maybe first a short demo on what the product would be. So I have here a test account on Strava, where I will just upload a GPX, so that's a ride that you would do with your bike, right? And that happens typically with your watch or your mobile phone or whatever you're doing, and you can see here, there's a ride, and I will give it a name, Igloo demo, and I will make sure it's a private one, that no one else is seeing it, because it's a fake ride. I wish I was riding it, but I was here in Finland preparing my session. So this has now been uploaded on Strava, and actually behind the scenes, they are calling a webhook, because I gave Kotakol the authorization to listen to this. And we are processing that. So we are processing the activity, and if all goes well, you can see here the description is empty. If I do an F5 here, and this can take a while because Strava is sometimes, taking a few minutes to get, the webhook called, and we have service bus behind the scenes. So you should see at least that there is an activity updated, and that you will see the calls that I have done. This is the application here, so the web app. As you can see, we have 8,000 people registered, so it's quite nice because of people seeing someone did a ride on Strava. They can see, oh, he conquered that list, so he has 5 different new climbs conquered. Oh, and there's the URL, so they go and look, because people want to collect things, right? This is not about being the fastest, this is about collecting as much as you can. And actually, zooming out here, let's go to the statistics. There are a few people that have been doing, we're crunching the numbers, and internet connection is not ideal, but there's a few people that have conquered all the 1,000 of these quota calls. So there's, I think, around 8 of them that have done it, and that's quite impressive if you ask me. Let's see if we can get the details here. I know, it will take some time. That's always the thing that happens when you give a live demo, that the webhooks and so on will always be a little bit later, but never mind. The unit tests is the thing that I think everyone is familiar with, and that you can quite easily write, and it's also something that is not taking a lot of time. They typically help with code correctness, also detecting the bugs quite easily, and also with refactoring. Refactoring is a part of your job quite often if you're a software developer, and doing that can result in some side effects. The more of these tests you have, the better, of course, that you're confident. What I always do and recommend is, if you have an issue, a bug, that you first write the test that fails, and that you make sure that the test becomes green. And what I also see quite often, if you build like libraries that people can use, or you have a framework and an open source thing, is that tests can quite often help in documentation to understand how you should use that application. Just by writing and using the tests, you expose the behavior that you expect to have. So you typically focus on the smallest piece of components. And while I'm totally not one of the people that would say, oh, you have to have a code coverage of X% with all the unit tests, I would say focus on the tests where it makes sense. And in my opinion, it's really on the helper classes in the libraries where you can have a lot of isolated parts that have to be tested. So common methods that I would test, for example, is in my front end, I think I have to do somewhere the print of a number. Like if it's the length of the climb has to be, and I get it in 1,500 meters, I would write it in 1.500 m, for example. So that's like, but it could be null, so I have to make sure that if it's below 0, then I put a line and things like that. So that's a very easy type of method to write, because you have a lot of behavior inside that method that you want to test. And then, of course, the thing that you quite often have, I assume most of you are familiar with the dependency injection that you typically use when doing API development and so on, where you have services that you inject. Sometimes these services are used to contact a repository, for example, the data registry, things like that, or you have external services. For unit tests, often you want to mock them away, so meaning that you don't integrate with the external services. And for that, you have mocking. So mocking is something that you can do. Here I have used the mock queue, so the mock library, where I have an interface, iTranslator service, and I say, for my test, instead of using my translator service that actually uses resource files that I would have to include in my tests, I say, I create a new mocking object of iTranslator service, and what I do, because in my test, the only thing I will do is making the get to return something. There I say, okay, if that method is being called, just return the initial value. That's, it's mocking up one thing instead of implementing a full test class in memory, for example, which is the thing that I did in the past. So, and there then I do my test just saying printed distance is equal that, and then I do my assertions. So that's typically unit testing, and that's also the smallest part of today, the thing that I think is most commonly known, and the thing where I will spend most of the time with is with the integration tests. So in my opinion, in a system, because looking back at Kotakol, but actually in most of the startups I'm involved with, you have backend logic. Think about messaging, things like Service Bus in Azure, things like databases. You have APIs, data that comes in. In the case of Kotakol, I'm having so the Strava webhook integration. I'm using key vaults because I have the tokens of my users, the refresh tokens and so on, to contact their information or to receive their information on the Strava API. These things are in key vault, right? The data is in the database of SQL Azure. So there's quite a lot of different dependencies that, that are being used. So unit testing is never enough, but of course, integration testing alone is also never enough. So you have to combine the things, again, where they are quite relevant. So the right one has the integration test working, but I think the unit test should be read in that one. So what's an integration test? And it's quite similar to system tests and so on. You have tests that you group functionally, and in the things that I have been testing so far, I mostly test against the API, because both for the application as the integration points, most of the things have been exposed through an API, so I typically don't include the front end as the web application or the app itself here. I test against my API, and that's quite important. So the next slides will go a little bit deeper in how to test ASP.NET APIs, both locally as in the cloud. For these things, I also use the real databases for integration tests. So a database or an external system, I would typically use it where it's relevant. And then the thing that ideally, because I'm the tester and I'm the developer, and that's never ideal, but budget is a reality in a startup. What is there that you have a separate team of testers, and they typically don't have to know and understand the implementation of the system. So the only thing that they have to do is write tests in a language they understand, and that they can do the that you can do the mapping to the implementations. And that's what we call black box testing. That's a theory. That's something that, to be honest, I have not seen too much. But yeah, it depends on how far you go. Typically, the higher the enterprise, the more it happens probably. So let's focus now on the API testing itself. So as I said, if you test your API, I think that is the key to start your integration tests. One thing that I use is NSWAG, and there's other tools for that, but I don't know if people know NSWAG. So if you have ASP.NET API, you can just install the NSWAG NuGet packages. They have a build package itself as well. And they allow you to automatically generate a client, a strong typed client, against your API. They also help you to generate the OpenAPI spec, so the JSON, and you can also tune these things, or the YAML, sorry, as files, which I also do to include them in my build and deployment pipeline. So we are using Azure API management, and in our repository, you will see the OpenAPI specs of our different APIs as artifacts. And I'm importing them at deploy time in Azure API management. So that's, if you've seen the session of Henry about Bicep, I'm having a Bicep module that gets the URL in my repository to that OpenAPI, and I'm just importing that in API management. So the good thing is that NSWAG is helping me to do all of that, and it also helps in strong typing my API tests, because actually I'm having a client, and I'm using that client to test against my API. That also means if my client would suddenly break because I have done a change of my API itself, and the client has been regenerated, and suddenly my client code breaks, in fact, I know that I have a breaking change in my API, and I should think about versioning, because if I have the breaking change in my strong typed client, probably the real consumers may have a similar thing. So let's go a little bit to a demo on how you typically set it up. So I assume most of you know how ASP.NET applications work, or APIs work. So what you can see here is in my project, and I will zoom in as soon as we get there. I have I just have a post-build event where the only thing I'm doing is I'm saying you have to generate this OpenAPI spec file. And by the way, you have to use the NSWAG client.json to generate that client API. And that is here. And what you can see here is that it will output to that specific file, so a CS file. It will output that, that client. So that is existing here in a different project, Web API client with just one file. I will just do a delete, and you will now see that I will, as you can see, probably on the bottom, I have 32 errors, so you know that I have exceptions now, because of course my file is gone. So if I now build my API, of course it could take a while, because now it's generating that JSON file, the OpenAPI spec for my deployment time, but it should also build if things go well. What's that sound? It's the... So as you can see now, by doing a real rebuild, there is automatically all the code generated. And you should see, for example, we have badges. So to collect stuff, you should see a badge API client, I guess. Like you have an interface and so on. So against that interface, I will be able to do get badge async. I will be able to do get badge for specific, all the list of badges and so on, right? So that's the nice thing that I use NSWAG for. And the next thing that I do then is I test locally. So it's What is important, of course, and that's the last slide of the session later, I do it in the CI/CD pipelines as well, so in my DevOps flow. But locally, when you do most of your development, before I make my pull request, or even for some functionality that I want to test, I just run my tests locally. And for that, I use my own local database, so I have the real database. I'm not mocking away these things. I use a local Docker image here, so it's running at this moment. But at another customer or company, we use against the Azure database that is deployed in the development resource group. So it's up to you. It's just a matter of connection strings that you use. And for some specific things, you can still inject test, stub, mock services. For example, for key vault integration, that's one of the things that I sometimes avoid, and I have like an in-memory class or a mock. Service bus integration is also something that I say, okay, for locally, I just run it, and I remove my messaging system. I replace my message service by something in memory, because I don't want to integrate with service bus. I just want to focus on some specific things. And I don't know if you're familiar with that specific package there, the ASP.NET Core MVC testing, but that's the one that allows me to run my API without having to do, to have the API really running as a project. So I don't have to do .NET run or F5 on my API project to test against it. What I do, I actually say, and that API is then hosted in the process of my tests, for example. And what I do, I create an application factory, API test application factory, that implements this specific abstract class. And I'm passing, and that's the important one, I'm passing the program.cs class. That may be ringing a bell, because that's the startup class from my API project. So I will go and show that. I think it's here. Yeah. So I have my application factory, and what I'm doing, I'm saying, okay, I'm creating the host. And by the way, this is the thing that I wanted to show. The program, as you can see, if I go here to my navigation, the program is in my actual web API project. I hope you can read enough, but that's the startup file where all the dependencies are being injected. For example, here, my activity log persistence service is this and ta-ta-ta-ta. So that's how the API is really starting up normally, but I'm also starting it up now in this web application factory. And what I do then specifically, I say I use everything that has been injected in the real service. The only thing that I change here, but you can change much more things, so I could override some specific services that I want to inject in my testing step. The only thing I do is, instead of using the SQL settings, so the configuration, the connection string, I'm using it from my own configuration object, and that's just locally. So I'm here saying I'm using the secrets, so the user secrets from my test application. And if you go here, I don't know if you're familiar with .NET user secrets, and don't take any pictures, but they are streaming this as well, right? Anyway, here we go. That's my connection string. You still have to be able to connect my database locally. But I'm using my local configurations of my tests. So I can test against a different database than I would run my application. But if I would specify something here, for example, services. I don't know what happens now. Let's be a little bit patient. So I hope you can understand that I could say services.add singleton and I overwrite the same interface in a different way, things like that. I could replace things. That's what I could do here for my testing. So instead of using my real key vault integration that I use for my deployed API, I could say, here I inject my own stub service in this case. How do we solve this? So now I'm on my login screen. Use Apple, they say. It's stable. All right. Apologies for this. Yeah, now you can see my music style. No. Oh no. What is this? I hope by now you get already an idea on how to test APIs, because this could take a while. This is crazy. Oh man. It's like my mouse is totally in a different, so what's the F5? No. Let's try it a bit like this. So as I said, you could override stuff here. So in this, Lambda, whatever it's called, you could add your own stuff for in case you're testing locally. So inject specific services. The next thing I then do is I have to create a HTTP client, of course, because you use the HTTP client to test against an API or to call an API. That HTTP client is the one that I have to pass to my generated code from NSWAG, so the step before. And what I'm doing here, I use this web application test factory, so the previous class that I've shown, and I say, okay, let's create a client now against that factory. So that's a client that works in process. And what I'm doing here, I can specify the base address. So if it's locally, it should be the local host, just like that. But I'm using the same tests in my CI/CD pipeline, or even locally if I say, oh, I want to test against my test environment and so on. And then I'm overriding by putting in the API base URL. So it's just a configuration parameter. So if the parameter is provided, I will test against the deployed API. If it's not provided, I will test locally inside the same process. Okay, so that's how these things work. And then a regular test would look like this. So this is XUnit, where you would say, okay, it's like a unit test that you write from structure, but I would test against there. So I'm here, for example, I'm saying this should throw an API exception because I'm just calling a user that has a random number, so the user will not exist, and I would get a 404. So I could do more of those tests, but just get the ID. Now, let's see if we can go back to here. Because the next step starts to look better. The next step that I want to show is how SpecFlow is something that I use. Someone familiar with SpecFlow? Not too much. I have some doubts about it, to be honest, because it's been a while since they really updated and brought out new versions. But I still think it's quite relevant and interesting, and there's good tooling inside the tools, for example, the one that I'm using, Rider. So it's a testing framework for behavior-driven testing to write human-readable acceptance tests, and that's the difference. Eh? So you have descriptive tests where you say, okay, I'm doing an implementation of the steps as a developer. So they have to implement the steps, but the cases can be written by the testers. That's the idea. So what you have features. And let's see if I can. I think we're good again. You have features. These are the ones that you would functionally describe your test. So I will show that in the next one. And then the features will translate. So they have a set of steps. They will translate into the implementation of steps. And these are code classes. And then you have hooks. Hooks are typically events that you can use to do a preparation or a cleaning. Imagine that you have generated a lot of new data in your tests. You could say something like, after my test, I will remove my test data from my data source, things like that. And a driver is the one where you would hide implementation details to keep your steps clean. So these are these items. But this is the interesting part. This is how a test case looks like, in my opinion. So I say, my scenario is, if an existing user checks his Strava activities, this is how it gets implemented. So given our test user, when the user reads 10 latest activities, then the activities should be valid and the number of activities should be 10. So this is a step. This is something that you understand. This is something that a tester could understand. What is the case here? That translates to a step with this attribute that's SpecFlow specific, and this is just an implementation that I do. So here I can specify whatever I need. I can get the data from my database and things like that. Here I'm also specifying something with the attribute when, because it maps that. But you can now see there's some kind of regular expression where the 10 becomes a variable, and the 10 becomes the variable that is being passed. So that's how you can specify input parameters towards your testing steps. The next thing is then this should happen, and then that should happen. So again, there you typically would, in the then methods, you would do your assertions. There you would say, I'm expecting the length to be 10 and things like that. Okay? What you also have is context injection. This is like keeping state between the different steps. So if you go back here, giving our test user, there I would, in that context, save the user ID, because I would use it, that same user ID in the second step to call my API with that user ID. So that's how things work. I can show that quite soon. Let's skip the drivers. And this is, for example, how you can do the hooks. So here I have my before scenario. So before I run that step, I'm actually initializing my driver. Behind the scenes, I'm just making that HTTP client that I can use to call against the API that I use. So these are attributes that you have. Before and after, typically, scenario step, feature, and things like that. All right? Let's go to the demo. If things go well. Jesus. Oh my God. Is there an option to restart my computer? Can I give that a try? Sorry, guys and girls. So it's probably related with the yeah, let's restart.
Put where your mouse is in the from the screen. If we have mouse problems.
So sorry for this. I think Saka has similar issues, so I'm good. If he can have issues, I can have. So what we've seen is an implementation of how to test against an API, and I was going to show how you can use SpecFlow, right, to write these functional descriptions and map them against, steps of the implementations. And now it's even dead. Oh no, it's starting up. So the next thing I will show after this is Azure load testing. Do people familiar with that? So not too much. So with Azure load testing, what I would show is how you can set up tests quite quickly, again against my API, and how these tests can then be run with different virtual users. And the last part I want to show is the UI testing. You cannot see it at this stage? Is there something specific I should do? Yeah, that's what I did. Oh, crap. No, it's not my screen. It's like a second display. So it's extended. Black magic, yeah. Okay, sorry again. So let's go back to the unit tests. And here are my functional tests. So if I click on, for example, the one that I have shown. No, let's go to the specs here. This is the one that I've shown. So this is just SpecFlow, a description, with the tooling, and I assume, because I'm not using Visual Studio, but I assume Visual Studio has similar plugins, I can just control-click, and then navigate to the test implementation. If I say, I also have something like IntelliSense, so you can see here, The user reads the latest 10 activities. So as a tester, you could imagine that it's intuitive if you have a library of all these steps implemented. So in here, for example, I'm having that state. This is just a POCO, so plain old object, class object, I guess, I don't know. But that gets injected here, so I could use that. So I can say in step 1, test state user ID equals X, and I could say here, for example, test state user, I could read it. So that's how you can, from one step to the other, keep some track. For example, that's what I do here. Test state achievements that I read from the API here, get user achievements. This is, by the way, just calling my generated API client from NSWAG. That's how things work. So if I just execute here, run tests, then I'm not having my Docker running. So this will probably be having, a timeout exception. But you can imagine that if my SQL starts up in time, that it becomes green. So I now got the test achievements, and I verified these things by implementing that in SpecFlow. All right? So back to the presentation. And sorry for speeding up a bit, but I think it's the only way to at least show the things I have built. The other one is so Azure load tests. So Azure load tests you just generate as a resource in your resource group. It's quite straightforward. And what you can do, you have different tests. So I don't know if people are familiar with JMeter. I'm not, but it seems it's built on top of JMeter, which is like an open source tool for performance tests. The thing that I have used is really this. So you can generate a test, you give it a description. I typically have to enable the advanced settings because what you typically have is you want to do more specific items. You specify your test URL, how much users you have, and things like that. But I'll go back to a test that I have created already, because you have to realize also if I start a new test, it typically takes time to spin up. So they have to spin up the instances, so it would take like 1 to 3 minutes before the test really starts. But this is a test that I have run earlier today. And what is nice there is that you actually have two side of metrics. So I specified, for example, that there's, I think, 2 agents. It runs for 20 minutes. And then you get the number of users at the same time. So I said 30 against my application. That's the response time, but I'm doing 5 different subsequent requests. So I'm simulating that I'm a user X. That user is receiving his achievements and so on. So that's like a scenario that I use with APIs. And I can see what calls are typically there. And this is like the 90th percentile. So all the calls, or 90% of the calls is faster than what you see. That's actually what is the 90%. So there again, it's important up front that you specify what you want to test and what you want to see as acceptance criteria. This is just a community application. Budget is limited. So this is more as demonstration purposes, but for other scenarios, this could be very important. So that's the client-side specifics. On the server-side metrics, I was able to say, and I think that's in the app components, I was able to say, okay, these and these and these components, so service bus, app service, my function, and things like that, or services that I know that will be hammered during this test. So you can add them, and you can also specify and see, oh, I had to scale out my functions. Oh, it seems that we have exceptions in this. So that's the whole thing. You can really monitor the utility and the usage of your backend systems that you have there. All right? Now, the last part, CD Kotako. So all of that was ready, of course, and I just had to go I think this is in the source. So npx Cypress run. Let's hope I'm doing this right. So the UI testing, Lightroom Classic. Why not? The UI testing that we have, or that I use, is cypress.io. It's also an open source tool. They have a cloud version where you can use their studio. It helps to automate your unit tests or your front-end tests against your deployed application. So you have Cypress Studio locally, and what I think is quite nice, you have also a test recorder. So you can just click in their studio, and it records the steps in your test case. And of course, you can easily see, okay, I have to clean up some things and so on, because it's sometimes not the best thing, but it's quite nice. So it looks like this, and I hope I can start it up. So I run my spec, and for every step that becomes green, I can also see what the state, how my screen looked like. So they are actually taking screenshots, and that could be quite nice. I haven't gone too far, to be honest, in their items, but I believe this could also be used for responsive testing. So you could say, I want to run it against a mobile device type of screen, so then my map should become different and so on. So that's something that you typically can run there. Some expressions, so it's JavaScript based. So Sci is like the object of Cypress itself. So there I can say navigating to a page is Sci.visit, and I go to climbs. So you can see this is a relative path, because the base URL, again, is something that is in my configuration file, and it will depend on if I'm testing in dev, test, production, right? The base URLs should change, but the relative path not. Here, for example, I'm saying I want to click a specific button, and that's the tip I would give if you're a front-end person. It's quite easy if you, in your HTML elements, like in this button, if you give them an ID, because then you can reference directly with the ID. If you follow the tests, like the recording studio, they would look in the, what's it called, the DOM, so the document object model, and you would get like this string to get a specific button. And I think this is much easier, because if you change your layout, the ID should be the same. So that's a tip, because I had, then the protocol ID is a variable that I did a random thing. So if I click that one, I will, that happens. You can also check for existence of elements, like protocol DOM was an ID on an element that should not exist because I had a session where I was not logged in. So I cannot say that you did the climb or not. So that's a test where I say, okay, something like that. And what I also had to do, for example here, just making sure that I have 1,000, because there's 1,000 calls, that the table itself contained 1,000 items. Is it open? Oh no, sorry. Yes. So this is how it works, and then we can finish. So you have end-to-end testing and component testing. I always have used end-to-end testing. So again, I cannot emphasize or explain enough about this one. And behind the scenes, by the way, my application is not running. cd git, cd protocol. It could be that, I don't know against which API I'm now running, so it could be that my tests fail, but you should see the gist. So you can test multiple browsers, by the way. I clicked Edge, but if you have Chrome installed and Safari, you can also test them. And then you can see here you have these tests, and this is how they run. So they are green. For example, here you can see what I do. I clicked the climb. I then get Kotakol 148, so that's just a random number. So I get that element, and if I click that element, as you can see, it's red, so they have been clicking that. Then it should have navigated to the other one, where I say, oh, there should be an elevation and so on. So that's the replay of my recording. So what I can do exactly is say, oh, I want to do a new test. So let's give it, I think map is the right URL. Yes, voila. So you see, I'm now recording a test on the left, and everything I do, you know, I click on this, all of these things are being recorded. If I click Save Comments, I can say map test. And I don't know if it's somewhere open still. Yes. I think map test is here. So you can see these items have been automatically generated. But as I say, this is the ugly part. This is if I change my layout, my test would break. So that's where I say use an ID so that you can reference your elements by a specific ID instead of having the layout specific items. That's the important part. So that was quite quick because of the issues you've seen. As a last slide, what I say is, of course, that you typically stick it together in your CI/CD. So I would say unit test is the thing because they don't cost you any time to run, typically. So I run them in every single phase and on every environment. But if I then do my CD, so my deployments, the unit tests and the integration tests and the UI tests, I run them against my environments that are not production, where I use the integration and the UI tests, of course, after my deployment has been done against my newly deployed environment. So it's like a post-validation. And in production, I would say the load tests, at least in the types of companies that I work with, are not automatically run. So because also Strava has rate limiting. So if I do a lot of load testing, I will be rate limited. So the load test is typically something you do on demand if you feel that it's needed, because resources are quite important for that. With that, I thank you for your patience, for coming to the best session on testing on Iglooconf, and thank you.
That was riveting. To stream, we bid adieu until tomorrow. So thank you everybody there on the other side of the screen. All of the materials, all the presentations will be in YouTube. So if something caught your attention today or tomorrow, you can check all of this later. Look at these presentations at half the speed to really catch everything up. To stream, bye-bye, see you tomorrow. And we will continue with the panel. We have a 10-minute-ish